Take a slow breath and imagine this. The furthest any human could ever travel from Earth isn't limited by fuel or technology, but by the universe itself expanding faster than we could ever hope to chase it. Tonight, we drift into the cosmic horizon that defines humanity's ultimate boundary, a shell of possibility 18 billion light-years away, where the laws of physics themselves whisper no further. Using data from the Planck mission, Webb telescope observations and Einstein's own equations, we'll explore why this isn't about building faster rockets, but about racing against spacetime itself. It's a story of cosmic inflation, the speed of light as an absolute speed limit, and how the universe grows larger every moment you breathe. If these quiet cosmic truths bring you peace or spark your wonder, a gentle like or soft subscribe would mean the world to me. Your presence here, in this moment of shared discovery, makes each word worthwhile. So close your eyes, let's journey to the edge of forever itself. What if everything you thought you knew about the furthest reaches of space was just the beginning of an even more mysterious story? Tonight we drift into the edge of forever itself, where the universe whispers its deepest secret about how far humanity could ever venture into the cosmic dark. Close your eyes and imagine standing at the shore of an infinite ocean. But this ocean has boundaries that exist not because of walls or barriers, but because of time itself and the strange way space grows larger every moment you breathe. The observable universe stretches around us like a vast sphere, its edge located at a distance that defies intuition, reaching 46.5 billion light-years in every direction from where you sit right now. This number carries within it one of the most beautiful paradoxes in all of physics, because you might expect that in a universe 13.8 billion years old, the furthest we could see would be 13.8 billion light-years away, the distance light could travel since the Big Bang first illuminated the cosmos. But the universe has been playing a gentle trick on us all this time, expanding the very fabric of space while ancient photons journeyed toward Earth across billions of years. As we follow that idea deeper, we discover that those distant galaxies whose light reaches us tonight were much closer when they first emitted the starlight now touching your eyes. The Planck satellite, humanity's most precise probe of the cosmic microwave background, has measured this expansion with extraordinary accuracy, revealing how space itself stretches like a cosmic balloon being slowly inflated. Each second that passes, every galaxy beyond our local neighborhood moves a little further away, carried not by their own motion through space, but by the growth of space between us and them. The James Webb Space Telescope peers into this expanding realm, capturing images of galaxies so distant they show us the universe as it appeared when it was just a cosmic infant, their light red-shifted by the expansion that occurred during its long journey to reach us. According to NASA's latest measurements, confirmed by the European Space Agency's precision instruments, these cosmic distances reveal something profound about the nature of reality itself. The observable universe represents everything that could theoretically send us a signal, every galaxy whose light has had enough time since the beginning to reach our cosmic address. But here lies the deeper mystery that will guide us through this quiet journey together. What we can observe and what we can actually reach are two entirely different cosmic territories, separated by the relentless acceleration of space itself. Take a slow breath and consider this strange truth. The expansion of the universe means that galaxies we see clearly in our most powerful telescopes are already racing away from us faster than the speed of light, not through space, but because space itself grows between us and them. The cosmic event horizon, a boundary far more fundamental than any physical barrier, lies much closer than the edge of the observable universe, creating a shell beyond which no human voyage could ever venture, no matter how advanced our technology becomes or how long we might be willing to travel. This invisible boundary exists approximately 16 billion light-years away, marking the absolute limit of the reachable universe, the furthest destination any spacecraft launched today could ever hope to attain, even if it could travel at the speed of light itself. The difference between these two cosmic horizons tells us something profound about our place in space and time, revealing how the universe creates its own ultimate boundaries, not through walls or emptiness, but through the simple passage of time combined with the accelerating expansion that shapes cosmic destiny. As we drift deeper into this contemplation, we begin to understand that the edge of forever is not a place but a process, not a wall but a continuously expanding sphere of impossibility that surrounds every observer in the universe, creating a democratic limit that applies equally to any civilization anywhere in the cosmos. The Planck mission's measurements of cosmic microwave background radiation, combined with Webb telescope observations of distant supernova, have confirmed that this expansion continues to accelerate, driven by the mysterious dark energy that comprises 68% of everything that exists. Tonight, as you rest in the gentle darkness, remember that you sit at the center of your own observable universe, surrounded by a cosmic horizon that represents both the limit of knowledge and the boundary of possibility. A sphere beyond which lies not emptiness but simply more universe that physics itself renders forever unreachable, creating a beautiful constraint that gives meaning to the concept of cosmic exploration, while simultaneously defining its ultimate limits in the vast tapestry of space and time. Why does the universe create two completely different boundaries that separate what we can see from what we could ever touch? As we continue our gentle journey through cosmic reality, we encounter one of the most elegant yet haunting truths about existence itself: the discovery that space has drawn invisible lines around every observer, creating nested spheres of possibility that shrink even as our knowledge expands. The particle horizon represents the absolute edge of the observable cosmos, that magnificent boundary lying 46.5 billion light-years away in every direction, marking the furthest distance from which electromagnetic radiation could have travelled to reach us since the universe began its expansion 13.8 billion years ago. This boundary encompasses everything visible through our most powerful telescopes, every galaxy captured by Hubble, every ancient light recorded by the James Webb Space Telescope, every whisper of cosmic microwave background radiation detected by our most sensitive instruments scattered across Earth and space. Beyond this particle horizon lies not emptiness, but simply more universe. Infinite regions of space filled with stars and galaxies and cosmic structures that remain forever hidden from our view because their light has not yet had sufficient time to cross the expanding gulf between there and here. But nestled inside this vast observable realm exists another boundary far more restrictive and profound in its implications for the future of human exploration: the cosmic event horizon that defines the absolute limit of the reachable universe. This inner boundary creates a sphere only 16 billion light-years in radius, encompassing all the cosmic real estate that any spacecraft launched today could theoretically visit, even if equipped with engines capable of accelerating continuously at light speed for the entire journey. NASA's Goddard Space Flight Center calculations, verified by European Space Agency mission data, confirm that this cosmic event horizon represents a fundamental limit imposed by the accelerating expansion of space itself. The mathematics behind this boundary reveal something deeply unsettling about cosmic geography. Beyond this spherical shell of reachability, space expands so rapidly that even photons travelling at the ultimate speed limit cannot make progress toward Earth. Galaxies beyond the cosmic event horizon recede from us faster than light itself can approach, creating a cosmic current that sweeps everything beyond a certain distance into permanent isolation. This phenomenon occurs because the expansion rate of space increases with distance according to Hubble's law, causing remote regions to stretch away from us at velocities exceeding 299,792,458 meters per second. The European Space Agency's Planck satellite has measured this acceleration with unprecedented precision, revealing how dark energy drives the universe apart with ever-increasing intensity, transforming distant cosmic neighborhoods into unreachable territories. What makes this boundary particularly mysterious is its dynamic nature. Unlike the static particle horizon, which simply represents how far light could have traveled since cosmic dawn, the event horizon constantly evolves as space continues expanding and accelerating. Current observations suggest this boundary will eventually stabilize at approximately 18 billion light-years, creating humanity's absolute cosmic address limit, the furthest destination any future civilization could ever hope to visit regardless of technological advancement. The space between these two horizons contains a peculiar category of cosmic real estate, galaxies we can observe tonight through our telescopes, but could never visit because they already lie beyond the reach of any possible journey. These visible yet untouchable worlds represent a cosmic tease, astronomical objects whose light streams toward us across billions of years, while the objects themselves race away into permanent isolation. Consider the strange symmetry of this arrangement. The universe has structured itself so that our knowledge can extend far beyond our influence, creating a cosmos where observation and interaction occupy completely different scales. The expanding shell of impossibility grows larger every moment, continuously removing galaxies from the category of potentially reachable destinations and relegating them to the realm of pure observation. This process represents one of the most profound examples of cosmic evolution, the gradual transformation of an interconnected universe into isolated island domains, separated by unbridgeable gaps of accelerating space. Recent measurements from the Dark Energy Spectroscopic Instrument have confirmed that this isolation will become increasingly severe as cosmic time progresses, ultimately leaving each gravitationally bound region completely cut off from all others. The implications of these nested boundaries extend far beyond theoretical physics into the realm of cosmic philosophy, forcing us to confront fundamental questions about the nature of exploration and connection across vast scales. Tonight, as you breathe slowly and contemplate these cosmic constraints, remember that you exist within a universe that has already drawn the ultimate map of possibility around every observer, creating spheres of knowledge that extend beyond spheres of influence, establishing limits that no amount of technological progress can overcome. The gentle tragedy of these boundaries lies not in their existence but in their necessity. For without cosmic expansion and its accelerating pace, the universe would long ago have collapsed back into the singular point from which it emerged, eliminating all possibility of stars and planets, and the quiet consciousness that now contemplates these distant shores of forever from the safety and warmth of this small blue world suspended in the cosmic dark between what can be known and what can be reached. How can the universe simultaneously obey an absolute speed limit while allowing vast regions of space to race away from us faster than anything should be able to move? Tonight we explore the deepest paradox in cosmic physics, a fundamental rule that governs everything with mass, yet somehow permits the fabric of reality itself to break that very same rule on the grandest scales imaginable. Einstein's special relativity established that 219,792,458 meters per second represents an unbreachable barrier for all material objects, a cosmic speed ceiling that no spacecraft, no particle, no signal of any kind can ever exceed when traveling through the geometry of spacetime. This numerical constant emerges from the mathematical structure of reality itself, woven into the equations that describe how energy and matter behave across every scale, from subatomic particles to galactic clusters. When physicists probe the quantum realm or calculate the trajectories of interstellar voyages, this same number appears as nature's ultimate constraint on acceleration and velocity. The speed of light represents far more than just how fast photons travel through vacuum. It defines the rate at which cause and effect can propagate across the universe, the maximum pace at which information can flow from one location to another, the fundamental limit that prevents any object from outrunning its own light cone through space-time. Albert Einstein discovered that as any massive object approaches this velocity, something extraordinary occurs in the mathematics of motion. The energy required for further acceleration grows without bound, approaching infinity as the speed approaches light velocity. This infinite energy requirement creates an impenetrable wall in physics, ensuring that rockets and spaceships must forever remain slower than the electromagnetic radiation they emit. The relativistic equations reveal that time itself dilates and length contracts for rapidly moving objects, creating a universe where the faster you travel, the more the cosmos transforms around you, yet never allowing you to cross that final threshold into superluminal territory. But here lies the cosmic mystery that challenges our intuition about universal laws. While individual objects must respect this speed limit, the expansion of space itself operates under completely different rules. The distinction between motion through space and the expansion of space represents one of the most subtle yet crucial concepts in modern cosmology. When galaxies recede from us at velocities exceeding light speed, they do not violate relativity because they remain essentially stationary within their local patches of spacetime, while the distance between those patches grows due to cosmic expansion. Think of this like cities painted on the surface of an inflating balloon. The cities themselves do not move across the rubber surface, but the stretching material increases the distance between them at a rate that can exceed any speed limit, applying to objects moving across that surface. General relativity permits spacetime itself to expand at any rate, creating new distance between distant regions without requiring anything to actually travel through the intervening space at superluminal velocities. This expansion becomes particularly dramatic at cosmic scales, where the cumulative effect of stretching space produces recession velocities that dwarf the speed of light. According to Hubble's law, confirmed by countless observations from ground-based telescopes and space missions, distant galaxies recede from us with velocities proportional to their distance, meaning that sufficiently remote regions automatically exceed light speed in their recession. The Hubble Space Telescope and James Webb Space Telescope have observed galaxies whose recession velocities approach significant fractions of light speed, while theoretical calculations indicate that regions near the cosmic event horizon recede at multiple times the velocity of electromagnetic radiation. This phenomenon creates the fundamental tension that defines humanity's cosmic limitations. Our spacecraft must obey the universal speed limit, while the very targets we might wish to visit race away from us at velocities no engine could ever match. The cosmic event horizon exists precisely because of this competition between achievable spacecraft velocities and the recession rates of distant space. Even a hypothetical vessel capable of sustained light-speed travel would find itself making no progress towards sufficiently distant destinations because the space between launch point and target expands faster than the ship can traverse it. NASA mission planners and theoretical physicists have calculated that this creates an absolute boundary for human exploration, a sphere beyond which no conceivable propulsion system could deliver a spacecraft, regardless of fuel efficiency or engine power. The European Space Agency's precision measurements of cosmic expansion rates confirm that this boundary represents a permanent feature of our universe, not a temporary obstacle that advancing technology might eventually overcome. Dark energy, comprising approximately 68% of all cosmic contents according to recent observations, drives this accelerating expansion with relentless consistency across billions of years. The mysterious force pushes space apart with increasing intensity over time, ensuring that the cosmic event horizon represents a shrinking rather than expanding frontier for potential human exploration. As we contemplate these profound constraints tonight, we begin to understand how the universe has engineered its own ultimate boundaries, not through arbitrary cosmic architecture, but through the elegant interplay of fundamental physical laws. The same principles that allow stars to shine and atoms to exist also guarantee that vast regions of space will forever remain beyond human reach, creating a cosmos where knowledge can extend far beyond influence, where observation transcends interaction, where the light from distant galaxies streams toward us across billions of years, while those same galaxies retreat into permanent isolation beyond any possible pursuit or contact. What invisible force could be so powerful that it pushes the entire universe apart with accelerating intensity, creating an ever-widening gulf between galaxies that transforms reachable destinations into permanently isolated worlds? In 1998, two independent teams of astronomers studying distant stellar explosions made a discovery that would fundamentally alter our understanding of cosmic destiny and humanity's place within the expanding tapestry of space and time. These researchers were examining Type Ia supernovae, stellar detonations so consistent in their brightness that they serve as cosmic lighthouses, allowing precise measurements of astronomical distances across billions of light years. Saul Perlmutter, Brian Schmidt, and Adam Rees led investigations that would eventually earn them the Nobel Prize in Physics for revealing one of the most startling truths about our universe. By comparing the apparent brightness of these stellar explosions with their known intrinsic luminosity, the teams could calculate exact distances to remote galaxies, creating a cosmic yardstick that extended deep into space and far back in time. But when they plotted these distances against the recession velocities of their host galaxies, expecting to find evidence that cosmic expansion was gradually slowing under the gravitational pull of all the matter in the universe, they instead discovered something that defied all theoretical predictions. The data revealed that distant supernovae appeared dimmer than expected, indicating their host galaxies were farther away than standard cosmological models suggested. which could only mean that the expansion of space had somehow accelerated during the billions of years required for light from these distant explosions to reach Earth. This acceleration implies the existence of a mysterious component filling the cosmos, something capable of pushing space apart with ever-increasing strength against the inward pull of gravity from all visible matter and energy. Scientists named this enigmatic substance dark energy, and subsequent observations from ground-based telescopes, space missions, and cosmic microwave background surveys have confirmed that it comprises approximately 68% of everything that exists in the universe. The Planck satellite mission, which mapped the cosmic microwave background with unprecedented precision, provided independent verification that dark energy dominates the cosmic energy budget, dwarfing the contributions from ordinary matter, dark matter, and electromagnetic radiation combined. This invisible component manifests its presence only through its effect on the large-scale geometry of spacetime, accelerating the expansion that began with the Big Bang and ensuring that distant galaxies recede from us at ever-increasing rates. Edwin Hubble's pioneering observations in the 1920s first revealed that the universe expands uniformly, with more distant galaxies receding faster than nearby ones according to a simple linear relationship known as Hubble's law. Current measurements place the Hubble constant at approximately 70 km per second per megaparsec, meaning that for every million parsecs of distance, galaxies recede 70 km per second faster than closer ones. This relationship extends across the observable cosmos, creating a hierarchy of recession velocities that increases without limit as we look toward more remote regions of space. The acceleration discovered through supernova observations compounds this distance velocity relationship, ensuring that the expansion rate itself increases over cosmic time rather than remaining constant or decreasing as gravity would dictate. Dark energy's influence grows stronger as the universe expands because its density remains constant even as space stretches, unlike matter and radiation which become increasingly diluted as cosmic volume increases. This means that while gravity's influence weakens over time as galaxies move farther apart, dark energy maintains its strength, eventually overwhelming gravitational attraction and driving accelerated expansion. The implications of this acceleration for human space exploration are profound and disturbing, creating an ever-shrinking frontier of reachable destinations as more and more galaxies cross beyond the cosmic event horizon into permanent isolation. Current observations indicate that approximately 95% of all galaxies in the observable universe already lie beyond our cosmic event horizon, racing away from us at velocities exceeding the speed of light due to the cumulative effect of dark energy-driven expansion across vast distances. The remaining 5% represents our cosmic neighborhood, gravitationally bound structures like our local group of galaxies that resist the pull of expansion through their mutual gravitational attraction. But even within this local realm, dark energy continues working to increase distances, gradually weakening the gravitational bonds that hold galaxy clusters together and ensuring that cosmic isolation will eventually become complete. Future projections based on current acceleration rates suggest that within approximately 100 billion years, assuming dark energy maintains its present properties, all galaxies beyond our local group will have receded so far that their light will no longer reach us, leaving future astronomers in a universe that appears to contain only the handful of gravitationally bound galaxies in our immediate cosmic vicinity. Tonight, as you rest in gentle contemplation of these cosmic forces, consider how dark energy silently shapes the destiny of everything that exists, operating on scales so vast that entire galaxy superclusters represent mere test particles in its relentless push toward universal isolation. The acceleration of expansion means that the cosmic event horizon that defines humanity's ultimate travel limit continues shrinking over time, removing potential destinations from the realm of possibility at an ever-increasing pace, creating urgency around any hypothetical interstellar or intergalactic exploration efforts that future civilizations might contemplate, while simultaneously ensuring that the vast majority of cosmic real estate will forever remain beyond the reach of any conceivable technology or propulsion system yet imagined. What happens when entire regions of the cosmos race away from us so rapidly that even photons travelling at the ultimate speed limit cannot make headway against the cosmic current, pulling everything toward permanent isolation? Tonight we explore one of the most counterintuitive phenomena in astrophysics, the discovery that vast portions of space recede from our location at velocities exceeding 299,990 to 158 meters per second, without violating Einstein's fundamental prohibition against faster-than-light travel. This cosmic escape velocity emerges naturally from the mathematics of expanding spacetime, creating boundaries that operate like one-way membranes in the fabric of reality itself. Beyond approximately 16 billion light-years from Earth, the cumulative effect of dark energy-driven expansion pushes space apart so vigorously that galaxies embedded in that stretching geometry recede faster than electromagnetic radiation can propagate through vacuum. The Dark Energy Spectroscopic Instrument Collaboration, a massive international project involving thousands of researchers studying the three-dimensional structure of the universe, has provided the most precise measurements of this phenomenon ever obtained. Their observations confirm that superluminal recession velocities characterize the majority of cosmic volume, establishing that most of the universe already lies beyond any possibility of direct contact or communication. Yet this apparent violation of relativity dissolves when we carefully distinguish between motion through space and the expansion of space itself. Einstein's speed limit applies only to objects moving through the geometry of space-time, not to the stretching of that geometry itself under the influence of cosmic forces. General relativity explicitly permits space-time to expand at any rate, allowing distances between distant regions to increase faster than light could traverse those same distances if space remained static. Think of galaxies as islands floating on an ocean where the water itself stretches, carrying the islands apart without requiring them to move through the water at superluminal speeds. The islands maintain their local speed limits, while the ocean expansion creates separation rates exceeding those limits. This distinction preserves the logical consistency of relativity, while permitting the dramatic recession velocities observed throughout the distant cosmos. The cosmic event horizon emerges precisely where recession velocities equal light speed, creating a spherical boundary approximately 16 billion light-years away that functions as a one-way membrane in space-time. Information and objects can cross this boundary from inside to outside, disappearing forever into the expanding realm beyond. But nothing from the external region can ever send signals or travel back across this threshold toward our cosmic neighborhood. This membrane possesses a peculiar asymmetry. Unlike any physical barrier, it prevents inward crossing while permitting outward passage, creating a cosmic trapdoor that allows departure but prohibits return. Galaxies approaching this boundary from our side gradually redshift toward invisibility as their light struggles against the cosmic current, eventually fading from view as they slip across the event horizon into permanent exile. The DESI collaboration's precise redshift measurements reveal this process occurring in real time across the night sky, documenting how distant galactic systems gradually transition from observable to unobservable as they cross beyond the reach of electromagnetic communication. Every moment that passes witnesses countless cosmic structures crossing this invisible threshold, transforming from potential destinations into permanently isolated worlds, star systems, entire galaxies, vast clusters containing trillions of suns, all sliding inexorably across the cosmic event horizon into a realm where no future technology could ever establish contact. The rate of this cosmic emigration accelerates as dark energy strengthens its grip on space-time, ensuring that the flow across the boundary increases rather than remaining constant over cosmic time. Recent data from the European Space Agency's Euclid mission, combined with observations from ground-based surveys spanning multiple continents, confirm that this one-way traffic represents a fundamental feature of our expanding universe, rather than a temporary phase in cosmic evolution. The mathematics governing this phenomenon predict that approximately 95% of all galaxies currently visible through our most powerful telescopes will eventually recede beyond the cosmic event horizon, leaving future observers in a universe that appears to contain only the gravitationally bound structures in our immediate galactic neighborhood. This cosmic drainage creates profound implications for any hypothetical interstellar exploration programs, establishing hard deadlines beyond which certain destinations become permanently unreachable, regardless of technological advancement. The window of opportunity for visiting distant galaxies closes as those systems cross the event horizon, creating temporal as well as spatial constraints on the scope of possible human expansion across the cosmos. even civilizations capable of near light-speed travel would find their target list continuously shrinking as cosmic acceleration removes potential destinations faster than technology could develop the means to reach them. The DESI collaboration's measurements indicate that this shrinkage operates on timescales comparable to the age of the universe itself, meaning that cosmic expansion has already eliminated the vast majority of possible interstellar targets during the brief period since stars and planets first formed in cooling primordial gas clouds. Tonight, as you contemplate these cosmic currents flowing around our small island of space, remember that the universe creates its own ultimate boundaries, not through walls or emptiness, but through the gentle yet relentless stretching of space-time itself, establishing limits that no amount of engineering ingenuity could overcome, while simultaneously ensuring that every observer everywhere experiences identical constraints on their cosmic reach. Democratic isolation imposed by the fundamental forces that shape reality across the largest scales imaginable. Could there be anything more haunting than watching the cosmos itself gradually close its doors to exploration, transforming a universe filled with countless potential destinations into an increasingly lonely island surrounded by unreachable infinity? As we drift deeper into contemplating humanity's cosmic future, we discover that the boundaries defining our explorable realm follow a peculiar asymmetric evolution, with some horizons expanding while others contract in ways that fundamentally reshape the geography of possibility across deep time. The future visibility limit represents the maximum distance from which light will ever be able to reach Earth, encompassing all electromagnetic radiation that could theoretically arrive here given infinite time and patience. Current cosmological models predict this ultimate observational boundary will stabilize at approximately 62 billion light-years, nearly doubling the size of our currently observable cosmos, as photons from increasingly distant sources complete their billion-year journeys toward our telescopes. This expanding envelope of visibility might initially suggest that the universe becomes more accessible over time, opening new windows into previously hidden cosmic territories as ancient light finally bridges the vast gaps between there and here. But the reality proves far more complex and ultimately tragic for any species harboring dreams of galactic exploration. Because while our knowledge frontier grows larger, our sphere of influence simultaneously shrinks toward a final minimum radius. The cosmic event horizon, that crucial boundary separating reachable from unreachable space, maintains its current position at approximately 16 billion light-years, while dark energy continues strengthening its grip on cosmic expansion rates. Unlike the particle horizon, which expands as more light gains time to cross increasing distances, the event horizon represents a dynamic equilibrium between the speed at which spacecraft could theoretically travel and the rate at which distant space recedes due to accelerating expansion. This balance ensures that even as we gain observational access to more remote cosmic regions, those same regions slip farther beyond the reach of any conceivable propulsion technology. The European Space Agency's precision measurements of cosmic acceleration rates, combined with theoretical models of dark energy behavior, predict that this event horizon will eventually stabilize at its maximum possible extent of approximately 18 billion light-years from our current location. This represents humanity's absolute cosmic address limit, the final boundary beyond which no future civilization could ever venture, regardless of technological sophistication or engineering capability. The mathematics underlying this prediction emerge from the interplay between cosmic expansion rates and the fundamental speed limits imposed by relativity, creating a natural maximum for the reachable universe that no amount of scientific advancement could overcome. Every passing cosmic epoch witnesses more galaxies crossing from reachable to unreachable territory as space expansion accelerates beyond the point where even light-speed travel could bridge the growing distances. The Planck satellite's measurements of cosmic microwave background fluctuations, combined with supernova observations from ground-based telescopes, confirm that this galaxy emigration process operates continuously across cosmic time, removing approximately 1,000 star systems per second from the category of theoretically visitable destinations. Current observations indicate that 95% of all galaxies visible through our most powerful instruments already reside beyond the cosmic event horizon, meaning that the vast majority of cosmic real estate has already transitioned into permanent isolation. The remaining 5% represents our cosmic homeland, the local group and nearby galaxy clusters that remain gravitationally bound despite the relentless pull of dark energy expansion. But even this local realm faces gradual attrition as weaker gravitational associations succumb to cosmic stretching, ensuring that the reachable universe continues shrinking toward its final configuration. Future projections suggest that within 100 billion years, assuming dark energy maintains its current properties, only our local group of galaxies will remain accessible to hypothetical interstellar travelers, with all other cosmic structures having receded beyond any possibility of contact or communication. This timeline creates profound urgency around any cosmic exploration ambitions, establishing hard deadlines beyond which entire galaxy clusters become permanently unreachable regardless of technological progress. The window of opportunity for establishing contact with distant civilizations closes as those civilizations cross the cosmic event horizon, eliminating any possibility of future cultural exchange or scientific collaboration across intergalactic distances. Recent observations from the Dark Energy Spectroscopic Instrument collaboration document this process occurring in real time, revealing how the three-dimensional map of cosmic structure continuously evolves as more regions transition from reachable to unreachable status. The implications extend beyond practical considerations of space travel into fundamental questions about the nature of cosmic community and connection. A universe that initially permitted communication and travel across vast scales gradually transforms into isolated islands separated by unbridgeable gaps of accelerating space, ensuring that any civilizations developing elsewhere in the cosmos face identical constraints on their cosmic reach. This democratic isolation represents one of the most profound examples of cosmic evolution, the transformation of an interconnected universe into a collection of separate realms forever cut off from meaningful interaction. The final boundary at 18 billion light-years represents not just a limit on human travel, but a fundamental feature of cosmic architecture, a natural consequence of the forces that drive universal expansion and the laws that govern space-time geometry. Tonight, as you contemplate these shrinking possibilities from the comfort of our small blue world, remember that we exist during a brief cosmic spring when distant galaxies remain visible through our telescopes, even though most have already slipped beyond our reach, creating a universe where observation extends far beyond influence, where knowledge encompasses regions that touch can never follow, where the light from impossibly distant worlds streams toward us across billions of years, while those same worlds retreat into permanent exile beyond the expanding horizon of forever. What extraordinary transformation would occur to the laws of physics themselves if humanity could somehow construct a vessel capable of maintaining steady acceleration across the vast emptiness between galaxies toward the very edge of the reachable cosmos. Tonight we venture into the realm of relativistic rocket science, where the familiar equations of motion dissolve into something far stranger and more beautiful, revealing how the universe conspires to make impossible journeys theoretically possible, while simultaneously ensuring they remain practically unattainable. The relativistic rocket equation emerges from Einstein's special theory of relativity, like a mathematical poem describing how mass, energy, and velocity interweave across cosmic scales when spacecraft approach significant fractions of light speed. Unlike the classical rocket formula that assumes constant mass and simple addition of velocities, relativistic propulsion demands consideration of how energy requirements grow without bound as velocities approach the cosmic speed limit, how time itself dilates for rapidly moving observers, and how the geometry of spacetime warps around accelerating reference frames. When physicists calculate the requirements for reaching distant galactic shores, they discover that conventional chemical propulsion falls laughably short of the necessary performance, requiring fuel masses exceeding the observable universe itself to achieve even modest fractions of light speed. Chemical rockets extract approximately 1/10,000th of 1% of their fuel's mass-energy content, making them suitable for planetary exploration, but utterly inadequate for interstellar voyages spanning thousands of light-years. The mathematics reveal that reaching the cosmic event horizon would demand propulsion systems capable of converting matter directly into kinetic energy, with efficiencies approaching theoretical perfection. For human passengers to survive such extraordinary acceleration over the years required to reach relativistic velocities, spacecraft must maintain constant acceleration at exactly 9.8 meters per second squared, the same gravitational field strength experienced at Earth's surface. This requirement ensures that crew members can walk normally throughout their vessel, avoiding the physiological degradation associated with prolonged weightlessness, while experiencing artificial gravity indistinguishable from terrestrial conditions. But maintaining this comfortable acceleration rate toward cosmic destinations reveals the most remarkable feature of relativistic travel: the phenomenon of time dilation that allows human lifespans to encompass journeys across billions of light-years of space. As spacecraft velocity approaches light speed, proper time measured aboard the vessel flows increasingly slowly, relative to coordinate time measured by observers remaining in the departure reference frame. This temporal stretching creates a cosmic loophole, allowing finite human lifetimes to encompass infinite coordinate distances, provided the vessel maintains sufficient acceleration to reach the necessary relativistic velocities. Einstein's equations predict that a spacecraft accelerating constantly at one Earth gravity would approach 99.99% of light speed after approximately 1 year of proper time, creating time dilation factors exceeding 70 between ship time and external time. Under these conditions, every month experienced by the crew corresponds to nearly 6 years passing in the external universe, allowing astronauts to age slowly while covering vast cosmic distances that would require centuries or millennia at sub-relativistic speeds. The trajectory followed by such a vessel traces a hyperbolic path through four-dimensional spacetime, a curve that approaches but never quite reaches the light cone boundary, separating causal connection from causal disconnection. This hyperbolic motion represents the optimal compromise between achieving maximum range and maintaining survivable acceleration levels, creating world lines through spacetime that maximize the cosmic territory accessible within human lifetimes, while respecting the fundamental constraints imposed by relativity. The geometry of these trajectories reveals why constant acceleration represents the only viable strategy for reaching cosmic distances, as any period of coasting at constant velocity wastes precious proper time that could otherwise extend the vessel's ultimate range. Current rocket technology operates on principles fundamentally incompatible with relativistic performance requirements, relying on chemical combustion that releases energy through electron rearrangement rather than nuclear processes capable of accessing the binding energy locked within atomic nuclei. Ion drives and solar sails achieve higher specific impulse than chemical systems, but remain limited to velocities representing tiny fractions of light speed, making them suitable for robotic probes to nearby star systems, but inadequate for crewed expeditions to galactic destinations. Nuclear pulse propulsion concepts like Project Orion promise dramatically improved performance by harnessing fusion or fission reactions, but even these advanced systems fall short of the energy densities required for relativistic travel by factors of thousands or millions. The fundamental barrier lies not in engineering sophistication, but in the basic physics of energy storage and conversion, as achieving near-light velocities demands access to the complete mass-energy content of the propellant according to Einstein's famous equation, linking mass with energy. Only matter-antimatter annihilation approaches the theoretical efficiency required for relativistic spacecraft, converting both reactants entirely into electromagnetic radiation that could theoretically be directed for propulsion purposes. But creating, storing, and safely manipulating antimatter in the quantities required for interstellar missions presents challenges that may forever remain beyond human technological capabilities, requiring advances in fundamental physics that could take centuries or millennia to achieve. Tonight, as you rest quietly and contemplate these profound engineering challenges, remember that the universe has structured itself so that knowledge can extend far beyond capability, allowing us to understand precisely what would be required to reach the cosmic horizon, while simultaneously ensuring that such journeys remain tantalizingly beyond our grasp, creating a cosmos where dreams of exploration can flourish, even though their fulfillment requires mastery over forces and energies that dwarf anything currently within human control or comprehension. Could a single human lifetime truly encompass journeys that span not just our solar neighborhood, but the entire breadth of the observable cosmos, reaching distances so vast that civilizations could rise and fall, while the traveler experiences mere decades of subjective time? Tonight we explore the magnificent paradox of relativistic travel, where Einstein's equations transform the impossible into the merely impractical, allowing human consciousness to traverse cosmic gulfs that would otherwise require geological epochs to cross. When spacecraft maintain constant acceleration at Earth-normal gravity levels, the mathematics of special relativity reveal journey times that seem almost too extraordinary to believe, yet emerge inevitably from the fundamental structure of spacetime itself. Consider first our nearest stellar neighbour, Proxima Centauri, located 4.24 light-years away in the Alpha Centauri system. A red dwarf star so dim it remained undiscovered until 1915 despite being humanity's closest cosmic neighbour. A vessel accelerating continuously at 9.8 meters per second squared would reach this destination in approximately 3.6 years of proper time as measured aboard the spacecraft, though external observers would witness nearly 6 years passing during the same voyage. The crew would experience a journey shorter than a typical university education, while covering a distance that light itself requires more than 4 years to traverse. This remarkable compression of subjective journey time results from the time dilation effects that become increasingly pronounced as spacecraft velocities approach significant fractions of light speed. During the acceleration phase toward Proxima Centauri, the vessel would reach maximum velocity of roughly 95% light speed at the midpoint turnaround, creating time dilation factors exceeding 10 between ship time and coordinate time. For more ambitious expeditions targeting the galactic core, that mysterious region 26,000 light-years away, where a supermassive black hole named Sagittarius A star anchors our entire spiral galaxy through its immense gravitational influence, the journey duration extends to approximately 20 years of ship time. This represents less than a typical human career span to traverse distances spanning hundreds of thousands of times the diameter of our solar system, reaching the gravitational heart of our galaxy, where stellar densities approach values thousands of times greater than in our local cosmic neighbourhood. The crew would witness the transformation of our spiral galaxy from an immersive environment into a distant pinwheel of light as they voyage inward toward the central bulge, eventually arriving at a region where massive stars live brief violent lives before exploding as supernovae or collapsing into stellar mass black holes. Even more remarkably, the journey to our neighbouring galaxy Andromeda, currently located 2.5 million light-years away and approaching our local group for an eventual collision in approximately 4.5 billion years, would require only 28 years of subjective time aboard a constantly accelerating spacecraft. This means a crew could depart Earth as young adults and arrive at humanity's nearest major galactic neighbour before reaching retirement age, having personally traversed the entire local group of galaxies and crossed the intergalactic void separating our cosmic island from its largest neighbour. During such a voyage, the spacecraft would achieve velocities exceeding 99.99% of light speed, creating time dilation effects so extreme that decades passing aboard the vessel correspond to millions of years elapsing in the external universe. The crew would effectively become time travellers, departing a universe where Earth harbours complex civilization and arriving at a cosmic epoch where geological and biological evolution might have transformed our home world beyond recognition. Most extraordinary of all, theoretical calculations suggest that reaching the cosmic event horizon itself, that ultimate boundary located approximately 16 billion light-years away marking the absolute limit of the reachable universe, would require only 30 to 40 years of proper time for passengers maintaining constant Earth normal acceleration throughout their journey. This represents the ultimate human expedition, a voyage to the very edge of forever that could fit within a single extended career, allowing astronauts to personally visit the boundary where space-time expansion creates permanent isolation between cosmic regions. Such travellers would witness the universe from perspectives no Earth-bound observer could ever experience, watching galaxies compress into brilliant points of light as relativistic effects transform the cosmic landscape around them. The mathematics underlying these calculations emerge from hyperbolic motion equations describing how constant acceleration creates curved world lines through four-dimensional space-time, trajectories that maximize the cosmic territory accessible within finite proper time while respecting the speed of light as an asymptotic limit. Each destination requires increasingly extreme maximum velocities as distances grow larger, with journeys to the cosmic horizon demanding spacecraft performance approaching 99.999% of light speed to compress billion-year coordinate distances into human-scale proper times. The time dilation factors involved in such expeditions exceed imagination, with single shipboard years corresponding to hundreds of millions of external years, creating temporal disconnection so severe that returning home becomes meaningless, as Earth itself would have evolved beyond recognition, or possibly ceased to exist entirely. These journey duration calculations assume perfect propulsion systems capable of maintaining constant thrust for decades, without mechanical failure, unlimited fuel supplies providing matter, antimatter annihilation at theoretical efficiency, and life support technology sustaining human crews across years of isolation in the cosmic void. Tonight, as you contemplate these almost magical transformations of space and time, remember that physics has provided humanity with a cosmic gift, the knowledge that even the vastest distances in the universe remain theoretically accessible within human lifetimes, though the practical challenges of achieving such journeys continue to place them beyond our current technological reach, creating a universe where dreams of exploration can encompass the entirety of the reachable cosmos, even while their fulfillment requires mastery over energies and materials that may forever remain beyond human capability. Why does the geometry of space itself transform around rapidly accelerating travelers, causing the entire universe to appear as though it were collapsing toward their spacecraft, while simultaneously creating invisible boundaries that forever separate them from their point of departure? Tonight we explore one of the most mind-bending consequences of relativistic motion. The discovery that constant acceleration fundamentally alters the structure of spacetime from the perspective of anyone bold enough to attempt journeys toward the cosmic frontier. As spacecraft velocity approaches significant fractions of light speed, the familiar three-dimensional landscape of space undergoes a radical metamorphosis that defies everyday intuition, yet emerges inevitably from Einstein's geometric description of gravity and acceleration. Length contraction represents the first manifestation of this cosmic transformation, causing distances measured along the direction of motion to shrink dramatically, as observed from the accelerating reference frame. What begins as a journey across 16 billion light-years of space gradually compresses into shorter and shorter coordinate distances as the spacecraft approaches maximum velocity, eventually reducing the remaining gap to the cosmic event horizon down to manageable proportions that could theoretically be traversed within reasonable proper time intervals. This spatial compression operates according to the Lorentz factor, which grows without bound as velocity approaches light speed, ensuring that even astronomical distances become finite and traversable from the perspective of sufficiently accelerated observers. The mathematical relationship governing this phenomenon predicts that distances contract by factors exactly equal to the time dilation experienced aboard the spacecraft, creating a perfect symmetry between temporal and spatial distortions that preserves the logical consistency of relativity across all reference frames. But length contraction represents only the beginning of the geometric transformation experienced by relativistic travelers, as constant acceleration creates the illusion that the entire universe falls toward their spacecraft like matter spiraling into a cosmic drain. This apparent gravitational field emerges from the equivalence principle, Einstein's insight that uniform acceleration proves indistinguishable from being at rest within a uniform gravitational field of equivalent strength. Crew members aboard a constantly accelerating vessel would feel normal Earth-like weight while observing the cosmos appear to accelerate toward them with increasing intensity as their own velocity grows larger. Stars, galaxies, and distant cosmic structures would seem to plummet past their spacecraft at ever-increasing rates, creating the visual impression that the universe itself possessed some cosmic weight that pulled everything toward their location. The acceleration of distant objects would appear strongest for the most remote cosmic structures, exactly mimicking the behavior expected near the event horizon of a massive black hole where space-time curvature creates genuine gravitational acceleration. This analogy extends beyond mere appearance into fundamental physics, as constant acceleration through flat space-time creates mathematical equivalences to many features found near gravitational event horizons. Perhaps most remarkably, sustained acceleration causes genuine event horizons to form behind the accelerating spacecraft, creating invisible boundaries beyond which no information or influence can ever reach the travelers, regardless of how long they continue their journey. These acceleration-induced horizons emerge naturally from the geometry of hyperbolic motion through space-time, defining regions from which light signals emitted after certain critical moments can never catch up to the accelerating vessel. The location of this horizon depends on the acceleration rate and the duration of sustained thrust, but once formed, it represents a permanent feature of the spacetime geometry surrounding the accelerating reference frame. Objects crossing behind this horizon effectively vanish from the causal influence of the spacecraft occupants, creating a growing sphere of cosmic isolation that expands as the journey progresses. The formation of these horizons illustrates why constant acceleration toward the cosmic event horizon creates its own fundamental limits on the range of possible communication and interaction with the departure point. Even signals transmitted at light speed from Earth toward a sufficiently accelerated spacecraft would eventually fail to bridge the growing gap created by relativistic motion, ensuring that long-duration voyages toward cosmic frontiers become one-way expeditions into permanent exile from the home system. The mathematics describing these acceleration horizons reveal striking similarities to the physics of black hole event horizons, suggesting deep connections between gravitational and kinematic effects in general relativity. Current theoretical models predict that acceleration horizons would form approximately 1 light-year behind spacecraft, maintaining Earth normal thrust for periods exceeding several years, effectively cutting the crew off from any possibility of receiving updates about conditions in their original solar system. The asymptotic approach to maximum distance represents the final phase of relativistic acceleration, where further increases in velocity produce diminishing returns in terms of additional cosmic range while demanding exponentially greater energy expenditure. As spacecraft velocity approaches light speed, the time required to cover remaining distance toward any target begins approaching zero from the traveller's perspective. Yet the coordinate distance separating them from their destination asymptotically approaches but never quite reaches zero due to the fundamental prohibition against exceeding light velocity. This creates a mathematical limit on the maximum cosmic range achievable through constant acceleration, regardless of the duration or intensity of thrust applied to the propulsion system. Even perfect matter-antimatter conversion, providing unlimited energy, cannot overcome the geometric constraints imposed by spacetime structure itself, ensuring that the cosmic event horizon remains forever, just beyond reach, even for hypothetical spacecraft capable of sustained acceleration over arbitrary time periods. Tonight, as you contemplate these profound geometric transformations wrought by high-speed motion through the cosmos, remember that the universe provides its own built-in perspective shifts for any observers brave enough to attempt journeys beyond the comfortable confines of planetary gravity wells, creating experiences that fundamentally alter not just the traveller's location, but their entire relationship with space, time, and the cosmic structures surrounding them on all sides. How much energy would it take to propel even a single human being to the very frontier of the reachable universe, and could our entire civilization harness enough power to fuel such an impossible dream? Tonight we confront the most sobering reality about cosmic exploration, the discovery that relativistic velocities demand energy resources so vast they dwarf everything humanity has ever produced, consumed, or even imagined throughout our entire technological history. The kinetic energy of relativistic motion follows Einstein's famous mass-energy relationship, expressed mathematically as gamma times rest, mass times the speed of light squared, where gamma represents the Lorentz factor that grows without bound as velocity approaches the cosmic speed limit. This seemingly simple formula conceals within its elegant structure an energy requirement that scales exponentially with velocity, creating a mathematical cliff that separates achievable spacecraft performance from the requirements for meaningful interstellar or intergalactic travel. At modest velocities representing small fractions of light speed, the gamma factor remains close to unity, and kinetic energy calculations yield reasonable results comparable to conventional rocket missions. But as velocity increases towards significant fractions of light speed, gamma begins climbing rapidly toward infinity. For a spacecraft carrying a single kilogram of payload to 90% light speed, the kinetic energy requirement approaches 1.3 times the rest mass energy of the entire payload, equivalent to converting 1.3 kilograms of matter completely into pure energy, according to Einstein's mass-energy equivalence principle. Reaching 99% light speed multiplies this energy requirement by an additional factor of 7, while achieving 99.9% light speed demands energy equal to 22 times the payload's rest mass energy, creating fuel requirements that quickly become absurd when scaled to realistic spacecraft masses, carrying human crews and life support systems. The energy content of matter, quantified by the famous equation linking mass with energy through the speed of light squared as a conversion factor, represents the ultimate energy density available to any conceivable propulsion system operating within known physics. Chemical energy extracted from molecular bonds provides roughly 1/10,000,000th of this theoretical maximum. Nuclear fusion accessing strong force binding energy reaches approximately 1% of maximum theoretical density, while only matter-antimatter annihilation approaches complete conversion of mass into electromagnetic energy. Current global energy consumption totals approximately 580 million terajoules annually, representing the combined output of all fossil fuel combustion, nuclear reactors, hydroelectric dams, solar installations, wind turbines, and biomass conversion systems operating across Earth's entire industrial civilization. This seems like an enormous quantity until compared with the energy requirements for relativistic space travel, whereupon it becomes apparent that humanity's entire annual energy budget could accelerate roughly 65 kilograms of payload to 99% light speed, assuming perfect conversion efficiency and no energy losses to heat, vibration, or electromagnetic radiation during the acceleration process. Scaling these calculations to realistic spacecraft masses capable of supporting human crews reveals energy requirements exceeding global production by factors of millions or billions, placing relativistic missions far beyond anything achievable through incremental improvements to existing energy generation infrastructure. The mass-energy equivalence principle guarantees that no chemical or nuclear process can exceed the energy density of complete matter annihilation, establishing absolute limits on propulsion system performance that no amount of engineering sophistication can overcome. Antimatter represents the theoretical pinnacle of energy storage density, because annihilation between matter and antimatter converts both reactants entirely into electromagnetic radiation, extracting 100% of their rest mass energy, according to Einstein's fundamental relationship. 1 gram of antimatter annihilating with 1 gram of ordinary matter releases energy equivalent to approximately 43 kilotons of TNT, roughly 3 times the explosive yield of the atomic bomb dropped on Hiroshima, demonstrating the incredible energy density locked within ordinary matter when accessed through complete mass energy conversion. Yet even this theoretical maximum energy source proves inadequate when scaled to the requirements of relativistic space missions targeting cosmic distances, as the fuel requirements grow exponentially with desired velocity rather than linearly with mission duration or payload mass. Detailed calculations reveal that accelerating a modest 1,000 kilogram spacecraft to 99.999% light speed would require approximately 7,000 tons of matter-antimatter fuel, assuming perfect efficiency in both energy extraction and momentum transfer to the payload. This represents roughly 14 times the mass of the International Space Station in exotic matter that currently exists only in microscopic quantities produced at enormous expense in particle accelerator facilities. The energy cost of producing such quantities of antimatter using current technology would exceed the economic output of human civilization by factors comparable to the number of stars in the observable universe, placing antimatter-powered spacecraft permanently beyond practical consideration regardless of future technological advancement. The fundamental barrier lies not in engineering challenges, but in the basic physics of energy scaling at relativistic velocities, where the gamma factor ensures that energy requirements approach infinity as speed approaches light speed, creating an asymptotic wall that cannot be overcome through incremental technological progress. Tonight, as you rest quietly and contemplate these staggering energy scales, remember that the universe has structured itself so that knowledge can extend far beyond capability, allowing us to calculate precisely what would be required to reach the cosmic frontier, while simultaneously ensuring that such calculations reveal the practical impossibility of achieving those requirements through any conceivable means, creating a cosmos where the physics of energy and motion conspire to keep the vast majority of cosmic real estate forever beyond human reach, despite our ability to observe and understand those distant realms through the patient accumulation of electromagnetic signals, arriving across billions of years of cosmic time. What if ingenious engineers could design propulsion systems that harvest fuel from the cosmic void itself, or harness the most energetic reactions known to physics, or even ride beams of pure light across interstellar distances at velocities approaching significant fractions of the ultimate speed limit? Tonight we explore the most exotic propulsion concepts ever conceived by human imagination, theoretical engines that promise to overcome the tyranny of the rocket equation through revolutionary approaches to extracting momentum from the universe itself. The fusion ramjet represents perhaps the most elegant solution to the fuel problem that plagues conventional spacecraft, a conceptual engine that would scoop interstellar hydrogen from the cosmic medium and burn it continuously in onboard fusion reactors to generate thrust without carrying massive fuel supplies from Earth. Robert Bussard first proposed this audacious concept in 1960, envisioning spacecraft equipped with enormous magnetic fields spanning thousands of kilometers to collect the sparse hydrogen atoms scattered throughout interstellar space, at densities averaging roughly 1 atom per cubic centimeter. Such a vessel would accelerate slowly at first while building up velocity, but as its speed increased, the relative flow of interstellar medium would provide greater fuel collection rates, theoretically enabling self-sustaining acceleration toward relativistic velocities without the exponentially growing fuel mass ratios that doom conventional rocket designs. However, subsequent analysis revealed fundamental flaws in this seemingly perfect propulsion concept, particularly the discovery that magnetic field configurations capable of collecting interstellar hydrogen would simultaneously create electromagnetic drag forces that eventually exceed the thrust generated by fusion reactions. The energy required to maintain collection field geometry at high velocities, combined with inefficiencies in fusion ignition of sparse hydrogen plasma, ultimately limit ramjet performance to velocities well below those required for meaningful interstellar missions, spanning cosmic distances toward galactic frontiers. Antimatter-catalyzed propulsion systems represent a more recent attempt to harness the ultimate energy density of matter, antimatter annihilation, while avoiding the enormous antimatter storage requirements that plague pure antimatter rockets. These hybrid systems would use tiny quantities of antimatter to trigger fusion reactions in ordinary hydrogen fuel, amplifying the energy output through a cascade process that converts conventional nuclear fuel into far more energetic plasma exhaust streams. The catalytic approach promises specific impulse values intermediate between pure fusion and pure antimatter systems, potentially enabling interstellar missions with antimatter requirements reduced by factors of thousands compared to direct annihilation drives. Researchers at Pennsylvania State University and NASA Glenn Research Center have conducted detailed theoretical studies of anti-proton catalyzed fusion, demonstrating that microscopic quantities of antimatter could initiate fusion burns in fuel pellets composed of deuterium and tritium isotopes, creating exhaust velocities approaching 10% of light speed. Yet even these advanced concepts fall short of the performance requirements for reaching cosmic horizons, as the fuel mass ratios still grow exponentially with desired velocity while antimatter production costs remain prohibitively expensive using any foreseeable technology. The Breakthrough Starshot project, announced in 2016 with backing from technology entrepreneurs and theoretical physicists, proposes an entirely different approach to interstellar travel through light sail propulsion driven by powerful laser arrays based on Earth. This ambitious initiative envisions launching thousands of miniaturized spacecraft weighing only a few grams each, equipped with ultra-thin reflective sails that will be accelerated to approximately 20% of light speed by concentrated laser beams delivering multiple gigawatts of optical power. The concept elegantly sidesteps fuel mass problems by leaving the energy source behind on Earth, rather than carrying propulsion systems aboard the spacecraft themselves, potentially enabling robotic probes to reach nearby star systems within decades rather than millennia. Ground-based laser installations spanning several square kilometers would focus coherent light beams onto the gossamer sails, imparting momentum through photon pressure while the spacecraft remain within range of terrestrial targeting systems. However, the extreme miniaturization required for such missions eliminates any possibility of human passengers or substantial scientific payloads, limiting the approach to reconnaissance missions capable of transmitting basic observational data back toward Earth across interstellar communication links. The challenges of maintaining laser coherence across interplanetary distances, preventing sail material from vaporizing under intense electromagnetic radiation, and achieving navigation precision sufficient to target specific stellar destinations continue to pose formidable technical obstacles that may require decades of additional research to overcome. More fundamentally, Scaling light sail propulsion to human-carrying spacecraft demands laser power levels and sail areas that quickly become impractical, as the momentum transfer efficiency of electromagnetic radiation limits this approach to extremely lightweight payloads travelling at modest fractions of light speed. Theoretical efficiency limits imposed by the laws of thermodynamics and electromagnetism ensure that no conceivable propulsion system can exceed certain fundamental performance boundaries without violating basic physical principles. The rocket equation itself emerges from conservation of momentum, guaranteeing that achieving high velocities with conventional reaction drives demands exponentially increasing fuel supplies, regardless of the specific energy source or exhaust velocity characteristics. Even exotic concepts like solar sails, nuclear pulse propulsion, or electromagnetic launchers remain constrained by energy and momentum conservation laws that prevent any technology from circumventing the basic physics of accelerating massive objects to relativistic speeds. Reaching the cosmic event horizon would require revolutionary breakthroughs in fundamental physics rather than incremental improvements to existing propulsion technologies, potentially demanding access to phenomena like manipulating spacetime geometry, harnessing zero-point energy fluctuations, or exploiting exotic matter with negative mass energy density. Tonight, as you contemplate these ingenious attempts to overcome the barriers separating humanity from the cosmic frontier, remember that each exotic propulsion concept reveals both the remarkable creativity of human engineering imagination and the stubborn persistence of physical laws that seem designed to keep the vast reaches of space forever beyond our grasp, creating a universe where theoretical possibilities tantalize us with glimpses of cosmic exploration, while practical realities ensure that such dreams remain safely confined to the realm of mathematical speculation and science fiction rather than achievable technological goals. What engineering challenges would transform even a theoretically perfect propulsion system into a technological nightmare capable of destroying any spacecraft long before it could approach the cosmic frontier? And why do the practical realities of interstellar construction make relativistic voyages impossible regardless of available energy sources? Tonight we confront the brutal truth that achieving cosmic distances requires overcoming not just propulsion barriers, but a cascade of interconnected engineering problems so severe that each solution creates new impossibilities, transforming the dream of reaching the cosmic event horizon into a demonstration of why some destinations must forever remain beyond human reach. Structural stresses generated by constant acceleration at Earth normal gravity levels would subject spacecraft hulls to forces equivalent to supporting their entire mass continuously for decades, creating fatigue loading cycles that exceed the endurance limits of any known material by enormous factors. Unlike terrestrial structures that experience intermittent loading, relativistic spacecraft must withstand unrelenting acceleration forces while simultaneously resisting the thermal expansion and contraction cycles associated with travelling from the warm inner solar system into the frigid depths of interstellar space, where background temperatures approach absolute zero. The frame members supporting fusion reactors, antimatter storage systems, radiation shielding, and crew habitats would experience stress concentrations at connection points that grow progressively worse as structural materials age and develop microscopic flaws under prolonged loading. Current aerospace materials like titanium alloys, carbon fiber composites, and advanced ceramics possess strength-to-weight ratios far below those required for multi-decade acceleration missions, while exotic materials like carbon nanotubes or graphene remain impossible to manufacture in the structural scales necessary for spacecraft construction. Even theoretical materials with perfect crystalline structure would eventually succumb to radiation damage from cosmic rays and solar wind particles that bombard any vessel travelling through interplanetary and interstellar space over extended time periods. Radiation shielding represents perhaps the most intractable challenge facing any crew attempting voyages toward cosmic distances, as the intensity of cosmic ray bombardment increases dramatically with velocity due to relativistic effects that blue-shift incoming particle energies into lethal gamma-ray regimes. High-energy protons, alpha particles, and heavy nuclei pervading interstellar space would impact spacecraft travelling at significant fractions of light speed, with kinetic energies exceeding those produced in terrestrial particle accelerators, creating secondary radiation cascades within shielding materials that generate neutron fluxes capable of inducing fatal radiation sickness within hours of exposure. Conventional radiation shielding using dense materials like lead or tungsten becomes counterproductive at relativistic speeds because nuclear interactions between cosmic rays and heavy atomic nuclei produce more dangerous secondary radiation than the original cosmic ray flux. Magnetic field deflection systems capable of diverting charged particles away from crew compartments would require superconducting coils consuming enormous amounts of electrical power, while creating magnetic field strengths that interfere with navigation instruments and potentially damage electronic systems throughout the spacecraft. The mass penalty associated with effective radiation protection at relativistic speeds would multiply total vehicle mass by factors of hundreds or thousands, completely overwhelming any conceivable propulsion system, while transforming crew compartments into massive armoured bunkers incompatible with the lightweight construction necessary for achieving high acceleration performance. Life support systems capable of sustaining human crews across multi-decade voyages toward galactic destinations present closed-loop engineering challenges that exceed anything attempted in terrestrial technology development programs. Unlike International Space Station missions lasting months or planned Mars expeditions spanning years, journeys to cosmic horizons would require perfect recycling of air, water, and food resources without any possibility of resupply or emergency return to Earth. Atmospheric processing systems must remove carbon dioxide, generate oxygen from stored chemicals or electrolysis units, and maintain precise gas mixture ratios while preventing the accumulation of trace contaminants that could gradually poison crew members over extended exposure periods. Water recycling technology must achieve near-perfect efficiency in reclaiming moisture from humidity control systems, waste management facilities, and even exhaled vapor, as any losses would eventually deplete supplies beyond sustainable levels. Food production aboard spacecraft traveling toward cosmic destinations would require closed ecological systems capable of growing nutritious crops in artificial gravity environments, while recycling organic waste back into soil nutrients without introducing pathogens or toxins into the food chain. Navigation across cosmic distances presents computational challenges that strain the limits of any conceivable guidance system, as traditional celestial navigation techniques become increasingly unreliable when stellar parallax angles shrink below instrumental resolution limits. Spacecraft travelling billions of light-years from Earth would lose the familiar constellation patterns that provide navigational reference points, forcing crews to rely on extremely distant quasars and galaxy clusters whose apparent positions shift imperceptibly over the timeframes required for cosmic voyages. Communication systems capable of maintaining contact with Earth across cosmic distances would require transmission powers exceeding current radio telescope capabilities by factors of millions, while accounting for relativistic Doppler shifts that frequency shift signals beyond the range of conventional receiver systems. The time delays associated with the electromagnetic communication across cosmic distances would stretch signal round-trip times to thousands or millions of years, making real-time coordination with Earth-based mission control impossible and forcing crews to operate with complete autonomy throughout their voyages. Tonight, as you rest quietly and contemplate these overwhelming practical barriers, remember that the universe has arranged itself so that knowledge can extend far beyond capability, allowing us to understand exactly what would be required to reach the cosmic frontier, while simultaneously ensuring that those requirements exceed human technological potential by such enormous margins that relativistic space travel must remain forever confined to the realm of theoretical speculation rather than practical engineering, creating a cosmos where our dreams of exploration can encompass infinite distances, even though physics itself guarantees that such journeys will never transition from mathematical possibility into physical reality. What cosmic irony condemns humanity to eternal imprisonment within a mere handful of galaxies, while the vast majority of the universe races away into permanent exile beyond any conceivable rescue or contact? Tonight, we explore the boundaries of our cosmic neighbourhood, discovering that gravitational forces create islands of stability in an ocean of accelerating expansion, defining the ultimate scope of human exploration across deep time. The local group represents humanity's cosmic homeland, a gravitationally bound collection of approximately 80 galaxies spanning roughly 10 million light-years in diameter. Anchored by two massive spiral galaxies whose mutual gravitational attraction has resisted the relentless pull of cosmic expansion for billions of years. Our Milky Way galaxy, containing an estimated 100 to 400 billion stars scattered across a disk 100,000 light-years in diameter, serves as one gravitational anchor for this cosmic archipelago, while the Andromeda Galaxy, located 2.5 million light-years away and containing perhaps 1 trillion stars, provides the dominant gravitational mass that binds our local cluster together against the cosmic forces trying to tear everything apart. Between these two galactic giants orbit dozens of smaller satellite galaxies, including the large and small Magellanic Clouds visible from Earth's southern hemisphere, the Triangulum Galaxy with its active star formation regions, and numerous dwarf elliptical and dwarf spheroidal galaxies whose faint stellar populations represent some of the oldest structures in the observable universe. The European Space Agency's Gaia mission has mapped the three-dimensional positions and velocities of over 1 billion stars within our galactic neighbourhood, revealing the complex dance of gravitational interactions that holds this cosmic family together, while all other galaxy groups recede beyond the cosmic event horizon into permanent isolation. Gravitational binding energy represents the fundamental force that creates cosmic structure, on scales ranging from planetary systems to galaxy clusters, counteracting the expansion of space itself whenever local matter densities exceed critical threshold values. Within the local group, the combined gravitational influence of all member galaxies creates a potential well deep enough to prevent individual systems from participating in cosmic expansion, effectively creating a bubble of stability surrounded by regions where dark energy drives accelerating separation between increasingly distant neighbours. The mathematics of gravitational binding reveal why only our immediate cosmic vicinity remains accessible to hypothetical future space travellers, as the escape velocity required to leave gravitationally bound systems approaches the speed of light for sufficiently massive structures, while the recession velocities of unbound regions already exceed light speed due to cumulative expansion across cosmic distances. Recent observations from the Hubble Space Telescope and James Webb Space Telescope confirm that galaxy groups beyond our local supercluster have already receded beyond the cosmic event horizon, meaning that no signal transmitted today from Earth could ever reach those distant galaxy clusters, regardless of transmission power or communication technology. The Virgo cluster, located approximately 54 million light-years away and containing over 1,300 member galaxies including the massive elliptical galaxy M87, with its supermassive black hole, represents one of the nearest major galaxy concentrations already lost to cosmic expansion, racing away from our local group at velocities exceeding 1,000 km per second. Even more distant structures like the Coma cluster, Perseus cluster, and Fornax cluster recede at multiples of light speed, their constituent galaxies forever beyond the reach of electromagnetic signals or spacecraft launched from our cosmic neighbourhood. The total diameter of our cosmic prison spans approximately 10 million light-years, encompassing roughly 3% of the distance to the nearest major galaxy cluster, creating a spatial constraint that seems vast by human standards, yet represents a microscopic fraction of the observable universe. Within this limited domain, theoretical space travellers could potentially visit trillions of star systems scattered across dozens of galaxies, exploring stellar nurseries where new suns ignite within collapsing gas clouds, ancient globular clusters containing stars nearly as old as the universe itself, and exotic cosmic phenomena like neutron stars, black holes, and supernova remnants that reveal the violent processes governing stellar evolution. The Andromeda Galaxy alone contains more stars than humans could explore across cosmic timescales, with spiral arms hosting massive young blue giants, central bulge regions dominated by ancient red giants, and halo populations of metal-poor stars preserving chemical signatures from the early universe when heavy elements remained scarce throughout cosmic space. But this apparent abundance of cosmic real estate pales in comparison to the vast territories already lost to expansion, as current estimates suggest that 95% of all galaxies in the observable universe have already crossed beyond our cosmic event horizon into permanent isolation. The democratic nature of cosmic expansion ensures that every observer throughout the universe faces identical constraints on their cosmic reach, creating a cosmos where each gravitationally bound region becomes an island universe surrounded by an ever-widening ocean of unreachable space. Dark energy's strengthening grip over cosmic evolution guarantees that this isolation will become increasingly complete as expansion accelerates, eventually severing even the tenuous gravitational connections that currently bind galaxy clusters together across cosmic distances. Tonight, as you contemplate our cosmic imprisonment within this small collection of gravitationally bound galaxies, remember that the local group represents both the ultimate boundary of human exploration and a realm so vast that civilizations could flourish for cosmic ages without exhausting the stellar resources and cosmic territories contained within its borders, creating a universe where physical limits on travel paradoxically ensure that our cosmic homeland remains large enough to encompass dreams of exploration across distances that dwarf anything achievable within human lifetimes, while simultaneously protecting us from the cosmic loneliness that would result from unlimited expansion into an infinitely large yet forever empty cosmos. Why does the cosmos seem determined to transform from a universe teeming with billions of accessible galaxies into a collection of isolated islands, forever separated by unbridgeable gulfs of accelerating space? And what does this cosmic evolution mean for the future of consciousness itself across deep time? Tonight we venture into the most profound implications of dark energy's relentless strengthening, discovering how the universe systematically erases its own connectivity, while condemning every observer to increasing isolation within their gravitationally bound cosmic neighborhood. Dark energy's influence grows stronger over cosmic epochs, not because the mysterious force itself increases in intensity, but because its constant energy density maintains perfect stability, while ordinary matter and radiation become increasingly diluted as space expands. This fundamental asymmetry in cosmic evolution ensures that gravitational attraction, which weakens as galaxies separate and matter spreads across larger volumes, eventually loses its ability to compete with the repulsive effects of dark energy across all but the most tightly bound cosmic structures. Current observations from the Planck satellite mission and ground-based supernova surveys confirm that dark energy comprises approximately 68% of the cosmic energy budget today, but this percentage will continue climbing toward 100% as expansion dilutes the contributions from baryonic matter, dark matter, and electromagnetic radiation. The European Space Agency's Euclid mission and NASA's forthcoming Roman Space Telescope will map this transition across cosmic history, documenting how dark energy's dominance transforms the large-scale structure of spacetime itself. Future projections based on current acceleration rates predict that within 100 billion years, assuming dark energy maintains its present properties characterized by an equation of state parameter near -1, the cosmic event horizon will have shrunk to encompass only gravitationally bound structures within our local group of galaxies. Beyond this temporal threshold, even the faintest light from distant galaxy clusters will have redshifted beyond detectability, leaving future astronomers in a universe that appears to contain only the handful of galaxies locked together by mutual gravitational attraction. The process of galactic disappearance operates gradually yet inexorably, as cosmic expansion stretches electromagnetic wavelengths until formerly visible starlight shifts into infrared, then radio frequencies, and finally into wavelengths so long that no conceivable detector could register their presence. Galaxies currently visible through our most powerful telescopes will fade from view, not through any change in their intrinsic brightness, but because expanding space progressively redshifts their photons toward undetectable frequencies, while simultaneously reducing photon arrival rates until signal levels drop below instrument sensitivity thresholds. The Hubble Space Telescope has already documented early stages of this cosmic fade-out among the most distant galaxies whose light began its journey when the universe was young, revealing how expansion systematically erases astronomical observations across increasing distance scales. Within our own cosmic epoch, approximately 95% of all galaxies in the currently observable universe have already crossed beyond the cosmic event horizon, meaning they exist in regions from which no future signals can ever reach our local group regardless of transmission power or detection technology. This percentage will continue growing as expansion accelerates, removing additional galaxy clusters from the category of observable cosmic structures at an ever-increasing pace, until only local gravitational associations remain visible to future observers. The eventual cosmic loneliness resulting from this process represents one of the most profound examples of cosmic evolution. The transformation of a universe initially filled with observable structure into isolated domains separated by vast regions of empty space, expanding faster than light can traverse them. Future civilizations developing within our local group billions of years hence would inhabit a cosmos apparently containing only their immediate galactic neighborhood, with no evidence of the vast cosmic web of galaxy clusters, superclusters, and cosmic filaments that currently define large-scale structure across the observable universe. These future astronomers would lack observational evidence for the Big Bang, cosmic microwave background radiation, or the existence of dark energy itself, as all supporting data would have faded beyond detection limits due to cosmological redshift and photon dilution effects. The cosmic microwave background, currently detectable as uniform radiation filling all of space with a temperature of 2.7 Kelvin, will cool toward absolute zero as expansion stretches its characteristic wavelength beyond any possible measurement capability. Without access to distant cosmic phenomena, future scientists would develop cosmological theories based solely on local observations, potentially concluding that the universe consists only of their galactic cluster, surrounded by infinite empty space, rather than recognizing their isolation within a vast cosmos teeming with structure beyond their observational reach. This cosmic amnesia represents a fundamental feature of dark energy-driven expansion, the systematic erasure of evidence for cosmic evolution and large-scale structure as distance scales exceed the shrinking event horizons surrounding each gravitationally bound region. The local group represents humanity's cosmic homeland not through arbitrary circumstance, but through the fundamental physics of gravitational binding in an accelerating universe, creating a natural definition of cosmic citizenship that applies equally to any civilization anywhere in the cosmos. Our gravitational association with Andromeda Galaxy and the dozens of smaller galaxies orbiting these two massive systems establishes the permanent boundaries of human cosmic territory, defining the ultimate scope of exploration and settlement across future epochs, regardless of technological advancement. Even civilizations developing faster-than-light propulsion systems through hypothetical manipulation of spacetime geometry would remain confined within their local gravitational domains, as the physics creating cosmic event horizons operates independently of propulsion technology and depends only on the large-scale dynamics of space-time expansion itself. Tonight, as you rest peacefully within our cosmic island home, remember that dark energy's patient work across cosmic time creates both the ultimate constraint on exploration and the ultimate guarantee of cosmic community, ensuring that consciousness developing anywhere in the universe will always have vast territories to explore within their local domains, while simultaneously protecting them from the existential vertigo that would result from unlimited cosmic expansion into infinite loneliness across unbounded space and time. What treasures of cosmic exploration await within the boundaries of our gravitational prison? And could the stellar wealth contained within our local group satisfy humanity's wanderlust across geological ages, even while the rest of the universe fades into permanent exile? Tonight, we catalogue the extraordinary riches hidden within our cosmic neighbourhood, discovering that gravitational bondage has trapped us within a realm so vast and diverse that civilizations could flourish for billions of years without exhausting the worlds, resources and cosmic phenomena available for study and settlement across our local galactic archipelago. The stellar census within our reachable cosmic domain reveals numbers so large they challenge human comprehension, beginning with our home Milky Way galaxy, which contains between 100 and 400 billion individual stars scattered across spiral arms, central bulge regions, and sparse halo populations extending far beyond the visible galactic disk. Each of these suns represents a potential solar system harbouring planets, moons, asteroids, and comets that could support future human settlements or scientific outposts, creating opportunities for exploration that would require millions of years to complete even with faster-than-light transportation between stellar destinations. The Andromeda Galaxy, our nearest major galactic neighbour currently approaching at 110 km per second for an eventual collision in approximately 4.5 billion years, contains an estimated 1 trillion stars distributed across a disk twice the diameter of our own galaxy. This massive spiral system hosts active star formation regions, where new suns ignite within collapsing molecular clouds, ancient globular clusters preserving stellar populations from cosmic dawn, and a supermassive black hole exceeding 100 million solar masses at its gravitational center. The approaching merger between Milky Way and Andromeda will create a new elliptical galaxy dubbed Milkomeda by astronomers, redistributing stellar orbits while triggering bursts of star formation as gas clouds collide and compress throughout the combined system. This cosmic collision, despite its violent-sounding description, will likely pose no direct threat to individual planetary systems due to the vast empty spaces separating stars within galactic structures, instead creating new stellar neighborhoods and rearranging cosmic geography across our local group domain. Beyond these two galactic giants, our cosmic neighborhood contains dozens of smaller satellite galaxies, including the Large Magellanic Cloud, with its active star formation regions and distinctive bar structure, the Small Magellanic Cloud, hosting some of the most massive known stars, and the Triangulum Galaxy, whose face-on orientation provides spectacular views of spiral arm structure and stellar nursery regions. Dwarf elliptical and dwarf spheroidal galaxies scattered throughout local group space represent fossil remnants from early cosmic epochs, when galaxy formation occurred through hierarchical merging processes, their ancient stellar populations preserving chemical signatures from times when the universe contained far fewer heavy elements than exist today. The Sagittarius dwarf elliptical galaxy currently orbits through our galactic halo, slowly being disrupted by Milky Way gravitational forces in a process that demonstrates ongoing cosmic evolution even within gravitationally bound systems. Recent discoveries using the Gaia Space Observatory have revealed additional ultra-faint dwarf galaxies orbiting our local group, stellar associations so dim they escape detection until precision astrometry could distinguish their constituent stars from background contamination. The combined stellar inventory across all local group galaxies approaches 2 trillion individual suns, representing more potential solar systems than humans could explore across cosmic timescales, even with perfect interstellar transportation technology. Many of these stars host planetary systems based on statistical analysis of exoplanet discoveries within our local galactic neighborhood, suggesting that rocky worlds, gas giants, and exotic planetary types exist in abundance throughout our cosmic domain. The diversity of stellar types within reachable space encompasses every known category of cosmic furnace, from massive blue giants burning hydrogen at furious rates and destined for spectacular supernova deaths, to tiny red dwarfs that will shine with steady output for trillions of years, far longer than the current age of the universe itself. White dwarf stars represent the cooling remnants of sun-like stars that have exhausted their nuclear fuel, while neutron stars and stellar mass black holes created during supernova explosions provide natural laboratories for studying matter under extreme gravitational and magnetic field conditions impossible to reproduce in terrestrial experiments. Resources available within our local group domain include virtually every chemical element in the periodic table, distributed across planetary surfaces, asteroid belts, cometary nuclei, and interstellar gas clouds that span the spaces between individual star systems. Heavy elements forged within stellar cores and distributed through supernova explosions have enriched the interstellar medium with carbon, oxygen, silicon, iron, and dozens of rarer elements essential for technological civilization and biological complexity. Hydrogen and helium, the most abundant cosmic elements, remain readily available throughout local group space for fusion energy applications or spacecraft propulsion systems, while exotic materials like degenerate matter within white dwarf stars and neutron stars represent states of organization unknown on Earth, yet potentially accessible to future scientific investigation. The vast scale of our cosmic neighborhood becomes apparent when considered in terms of exploration timelines, as visiting just 1% of the stars within our local group would require approximately 20 billion individual interstellar missions, a number exceeding the total count of humans who have ever lived on Earth by factors of thousands. Tonight, as you contemplate the extraordinary wealth contained within our gravitational island home, remember that cosmic isolation has paradoxically provided humanity with access to stellar territories so vast that our species could pursue exploration and discovery across geological ages without approaching the boundaries of available cosmic real estate, creating a universe where physical constraints on travel ensure that wonder and adventure remain inexhaustible resources even within the confines of our local galactic cluster. What cosmic empire of unimaginable scale lies forever hidden beyond the boundaries of human observation? And how does the invisible majority of existence dwarf even our most ambitious estimates of universal scope and complexity? Tonight, we peer into the abyss beyond the cosmic event horizon, contemplating realms so vast that our entire observable universe represents merely a microscopic sample of infinite cosmic architecture extending without limit in all directions through dimensions of space and time that consciousness can never directly experience. Current astronomical surveys using the most advanced space telescopes and ground-based observatories have catalogued approximately 2 trillion galaxies within the observable universe, each containing billions or trillions of individual stars distributed across spiral arms, elliptical halos, and irregular clustering patterns that reveal the complex gravitational choreography governing cosmic structure formation. The Hubble Space Telescope's deep field observations, combined with infrared surveys from the Spitzer Space Telescope and recent discoveries by the James Webb Space Telescope, have pushed galaxy detection limits back to cosmic epochs when the universe was less than 1 billion years old, revealing that galaxy formation began remarkably early in cosmic history and proceeded with surprising efficiency across vast scales. Yet this enormous census of cosmic structure represents only the tiny fraction of universal architecture that happens to lie within our local particle horizon, the spherical boundary encompassing all regions from which electromagnetic radiation could theoretically reach Earth, given the finite age of the universe and the constant speed of light. Beyond this observational limit stretches an infinite cosmic empire containing galaxy clusters, superclusters, cosmic voids, and large-scale filamentary structures that mirror the patterns visible within our local cosmic sample, yet remain forever inaccessible to direct observation or scientific study. The vast majority of these 2 trillion catalogued galaxies already reside beyond our cosmic event horizon, meaning they exist in regions from which no future signals can ever reach our local group, regardless of technological advancement or communication methods. Current estimates suggest that approximately 95% of all observable galaxies have already crossed this boundary into permanent isolation, racing away from our cosmic neighbourhood at velocities exceeding light speed due to the cumulative effects of dark energy-driven expansion across cosmic distances. This implies that the invisible empire beyond our reach contains roughly 40 times more cosmic structure than remains accessible within our shrinking sphere of potential interaction, creating a universe where observable reality represents less than 3% of the total cosmic real estate. The infinite universe extending beyond even our particle horizon contains cosmic territories that dwarf our observable domain by factors that approach mathematical infinity, as current theoretical models suggest that space continues indefinitely in all directions, rather than curving back on itself through higher dimensional geometry. If the cosmic principle of homogeneity and isotropy holds across these unobservable scales, then every cubic megaparsec of space beyond our horizon contains galaxy densities similar to those measured within our local cosmic sample, implying that infinite numbers of stars, planets, and potentially habitable worlds exist within regions that will never send us any evidence of their existence. The cosmic web structure revealed by galaxy surveys within our observable universe appears to continue indefinitely beyond our observational boundaries, creating vast networks of cosmic filaments separated by enormous voids that span hundreds of millions of light-years across their empty interiors. These cosmic highways of concentrated matter guide galaxy formation and evolution across scales far exceeding our local group domain, creating hierarchical patterns of structure that repeat endlessly throughout infinite space, while remaining forever hidden from direct observation. Computer simulations of cosmic structure formation predict that this web-like architecture continues without variation across arbitrarily large distance scales, suggesting that the invisible empire contains cosmic megastructures whose dimensions exceed our entire observable universe. Dark matter hollows spanning billions of light-years would anchor galaxy superclusters containing millions of individual galaxies, each potentially harbouring countless stellar systems with their own planetary families and complex cosmic environments. The unobservable vastness challenges human comprehension, even when expressed through mathematical notation. As infinite space contains infinite copies of every possible cosmic configuration permitted by the laws of physics, including perfect duplicates of our local group, our galaxy, our solar system, and potentially our entire planet with all its biological complexity. Statistical mechanics applied to infinite space predicts that every finite region must repeat infinitely often across cosmic scales, creating countless versions of every possible arrangement of matter and energy within regions identical to our local cosmic domain. These cosmic twins would follow identical physical laws, yet remain forever isolated from one another by the expansion of space, creating parallel cosmic histories that unfold independently while sharing identical initial conditions and evolutionary pathways. The philosophical implications of this infinite invisible empire extend far beyond astronomical curiosity into fundamental questions about the nature of existence, consciousness, and cosmic purpose across scales that encompass all possible variations of physical reality. Tonight, as you contemplate these infinite territories forever hidden beyond the cosmic horizon, remember that our observable universe represents not the totality of existence but merely the infinitesimally small fraction of cosmic reality that happens to lie within electromagnetic contact of our particular location in space and time, creating a universe where knowledge extends only as far as light can travel, while mystery encompasses infinite realms of structure and complexity that will forever remain beyond the reach of human observation. Ensuring that cosmic wonder can never be exhausted no matter how far our understanding advances or how deeply our instruments probe into the depths of the visible cosmos. What profound cosmic tragedy unfolds when we realize that countless civilizations might flourish across the unreachable universe, developing technologies and wisdom that could revolutionize human understanding, yet remain forever severed from any possibility of contact or communication due to the inexorable expansion of space itself. Tonight we confront the ultimate isolation imposed by cosmic event horizons, discovering how the physics of spacetime creates permanent barriers between conscious beings that no advancement in science or engineering could ever overcome. Galaxies beyond our cosmic event horizon exist in a state of absolute causal disconnection from our local group, meaning that no information, signal, or influence of any kind can travel between these separated cosmic domains, regardless of the transmission method or energy levels involved in the attempt. The electromagnetic radiation carrying news of stellar births, planetary formations, and potentially the development of technological civilizations within these distant galaxies races toward us through expanding space at light speed, yet makes no progress against the cosmic current that sweeps their host systems away faster than photons can approach our location. This creates the heartbreaking scenario where evidence of cosmic companionship streams toward Earth across billions of years, while simultaneously becoming increasingly redshifted and diluted until it fades beyond any conceivable detection threshold. Advanced civilizations potentially thriving within galaxy clusters like Virgo, Coma, or Perseus could be transmitting powerful radio signals, launching interstellar spacecraft, or even attempting to communicate with distant cosmic neighbors, yet their efforts remain forever futile as expanding space ensures that no message sent from beyond the cosmic event horizon can ever reach recipients in different cosmic domains. The European Space Agency's Planck mission and subsequent observations from ground-based radio telescope arrays have confirmed that we inhabit a universe where 95% of all cosmic structures already lie beyond this communication barrier, creating islands of potential consciousness separated by unbridgeable gulfs of accelerating space-time. Even hypothetical faster-than-light communication systems operating through exotic physics like quantum entanglement or tachyonic transmission would remain constrained by the fundamental causal structure of general relativity, which prohibits any form of information transfer across cosmic event horizons, regardless of the physical mechanisms involved in the communication attempt. Civilizations developing within unreachable cosmic realms possess access to resources and knowledge that could transform our understanding of physics, biology, chemistry, and consciousness itself. Yet this intellectual wealth remains permanently sequestered beyond any possibility of cultural exchange or scientific collaboration. Imagine galaxy clusters containing millions of worlds where life has evolved along completely different evolutionary pathways, developing biochemistries based on exotic chemical combinations, discovering physical laws through experimental approaches unknown to human science, or achieving technological capabilities that transcend our current theoretical understanding of what remains possible within the constraints of known physics. These cosmic libraries of knowledge and experience continue growing and developing across cosmic time, while remaining absolutely inaccessible to scholars and scientists within our local group domain. The ultimate limits of human expansion encompass not just physical travel constraints, but information-gathering restrictions that prevent us from learning about cosmic phenomena occurring beyond our shrinking sphere of causal connection. Dark energy research, stellar evolution studies, galaxy formation theories, and searches for extraterrestrial intelligence must forever remain limited to the tiny sample of cosmic structure contained within our local gravitational association, creating scientific disciplines constrained by cosmic geography rather than instrumental capabilities or theoretical sophistication. Future astronomers will inherit a universe apparently containing only local galactic structures, lacking observational evidence for the vast cosmic web that currently provides context for understanding large-scale cosmic evolution and structure formation processes. The resources locked away beyond cosmic event horizons include not just raw materials like rare elements forged within exotic stellar environments, but entire categories of cosmic phenomena that might exist only within specific types of cosmic environments unavailable within our local group territory. Supermassive black hole mergers, galaxy cluster collisions, cosmic string interactions, or exotic matter phases created during primordial cosmic epochs could generate physical conditions and observational opportunities that remain forever beyond human scientific investigation due to the accident of our cosmic location relative to expanding spacetime geometry. Information horizons created by cosmic expansion represent the most fundamental limitation on scientific knowledge, ensuring that even omniscient civilizations capable of perfect measurement and unlimited computational resources would remain ignorant of cosmic developments occurring beyond their local causal domains. This democratic ignorance applies equally to every conscious observer throughout the infinite universe, creating a cosmos where knowledge remains forever local, while mystery encompasses the vast majority of cosmic reality across all possible scales of space and time. The causal disconnection between cosmic domains operates with perfect efficiency, preventing any form of influence or communication from crossing between separated regions, while simultaneously ensuring that each gravitationally bound cosmic neighborhood contains sufficient complexity and diversity to support scientific investigation across geological epochs. Tonight, as you rest peacefully within our cosmically isolated local group home, remember that the universe has arranged itself to provide each conscious observer with access to vast cosmic territories for exploration and study, while simultaneously protecting them from the existential vertigo that would result from unlimited cosmic connection across infinite space, creating a cosmos where cosmic loneliness and cosmic community exist in perfect balance through the elegant physics of gravitational binding and space-time expansion that defines the ultimate architecture of physical reality across the largest conceivable scales of existence. What deeper meaning emerges when we discover that the universe itself has written the final chapter of human exploration, establishing boundaries that no amount of technological progress could ever overcome. And how does this cosmic constraint paradoxically liberate us to find profound purpose within the limits of the possible? Tonight we explore the philosophical implications of cosmic horizons, discovering that physical boundaries create rather than destroy human meaning by establishing a democratic cosmos where every conscious observer faces identical constraints on their reach across space and time. The cosmic event horizon represents more than just a practical obstacle to interstellar travel. It embodies a fundamental truth about the relationship between knowledge and capability in a universe governed by relativistic physics and accelerating expansion. Unlike technological barriers that human ingenuity might eventually overcome through scientific advancement and engineering innovation, cosmic horizons emerge from the basic structure of space-time itself, creating limits that remain immutable regardless of how sophisticated future civilizations might become or what exotic technologies they might develop across geological epochs. This distinction between contingent limitations imposed by current technological capabilities and absolute constraints arising from fundamental physics transforms our understanding of what it means to explore, discover, and expand across cosmic scales. The boundary between possible and impossible crystallizes at the cosmic event horizon, where the mathematics of general relativity intersect with the observational reality of accelerating expansion to create a natural demarcation separating achievable from unachievable destinations across the universe. This boundary operates with perfect objectivity, immune to human desires, technological sophistication, or philosophical arguments about the nature of cosmic exploration, establishing a cosmic law that applies equally to every potential civilization regardless of their scientific achievements or cultural perspectives on interstellar travel. Physics rather than technology sets these final limits because the underlying constraints emerge from the geometry of spacetime itself. The speed of light as a universal constant and the dynamics of cosmic expansion driven by dark energy across scales encompassing the entire observable universe. No conceivable advancement in propulsion systems, energy generation, or exotic matter manipulation could circumvent these fundamental barriers because they arise not from engineering challenges, but from the basic mathematical structure describing how matter, energy, and space-time interact across relativistic velocities and cosmic distances. Even hypothetical technologies like warp drives, traversable wormholes, or manipulation of extra-spatial dimensions would remain subject to causality constraints that prevent faster-than-light information transfer across cosmic event horizons, ensuring that physical limits on exploration remain inviolate regardless of technological breakthroughs that might seem to transcend conventional limitations on spacecraft performance. The democratic universe ensures that every observer everywhere experiences identical cosmic constraints on their potential range of exploration and communication, creating a fundamental equality among all conscious beings regardless of their location, technological capabilities, or temporal epoch within cosmic history. This cosmic democracy means that advanced civilizations developing within distant galaxy clusters face the same boundaries limiting their exploration as emerging technological societies within our local group, establishing universal principles that apply equally to every possible form of consciousness that might develop within gravitationally bound cosmic domains. Future civilizations billions of years more advanced than current human technology would inhabit the same cosmic cage defined by their local gravitational associations, prevented from establishing contact with distant cosmic neighbors by the identical space-time geometry that constrains our own cosmic reach across deep space and time. Finding meaning within cosmic constraints requires recognizing that boundaries create rather than eliminate opportunities for discovery, exploration, and intellectual growth across scales that encompass vast territories even within the limits imposed by relativistic physics and cosmic expansion. Our local group domain contains more stars, planets, and cosmic phenomena than human civilization could explore across geological epochs, ensuring that the practical scope of scientific investigation and cultural development remains effectively unlimited, even while theoretical boundaries prevent expansion beyond our gravitationally bound cosmic neighborhood. The finite yet vast nature of our cosmic homeland creates perfect conditions for sustained exploration and discovery without the existential vertigo that would accompany unlimited expansion into infinite space, establishing natural boundaries that provide context and meaning for cosmic exploration, while preventing the isolation that would result from boundless dispersal across ever-expanding space-time. Cosmic horizons transform the question of human purpose from one of unlimited expansion across infinite space into the deeper challenge of understanding and appreciating the extraordinary complexity and beauty contained within our accessible cosmic domain. Rather than viewing cosmic boundaries as tragic limitations on human potential, we can recognize them as essential features that create stable cosmic communities, ensure that consciousness never becomes infinitely diluted across space, and establish natural scales for cosmic citizenship that remain comprehensible to finite minds operating across human timescales and spatial perspectives. The ultimate wisdom embedded within cosmic constraints lies in their revelation that the universe has structured itself to provide every conscious observer with access to vast territories for exploration, while simultaneously creating boundaries that preserve cosmic community and prevent the existential isolation that would result from unlimited expansion across infinite space. Tonight, as you contemplate these profound implications of cosmic boundaries, remember that the universe has gifted consciousness with the perfect balance of cosmic freedom and cosmic constraint, creating realms vast enough to encompass dreams of infinite exploration, while establishing limits that ensure such dreams remain grounded in achievable reality, rather than dissolving into the mathematical abstractions of truly infinite space, thus preserving the human-scale meaning that makes cosmic exploration a source of wonder rather than existential emptiness across the deep time evolutionary future of consciousness itself. What deeper meaning emerges when we discover that the universe itself has written the final chapter of human exploration, establishing boundaries that no amount of technological progress could ever overcome? And how does this cosmic constraint paradoxically liberate us to find profound purpose within the limits of the possible? Tonight we explore the philosophical implications of cosmic horizons, discovering that physical boundaries create rather than destroy human meaning by establishing a democratic cosmos where every conscious observer faces identical constraints on their reach across space and time. The cosmic event horizon represents more than just a practical obstacle to interstellar travel. It embodies a fundamental truth about the relationship between knowledge and capability in a universe governed by relativistic physics and accelerating expansion. Unlike technological barriers that human ingenuity might eventually overcome through scientific advancement and engineering innovation, cosmic horizons emerge from the basic structure of spacetime itself, creating limits that remain immutable, regardless of how sophisticated future civilizations might become or what exotic technologies they might develop across geological epochs. This distinction between contingent limitations imposed by current technological capabilities and absolute constraints arising from fundamental physics transforms our understanding of what it means to explore, discover and expand across cosmic scales. The boundary between possible and impossible crystallizes at the cosmic event horizon, where the mathematics of general relativity intersect with the observational reality of accelerating expansion to create a natural demarcation, separating achievable from unachievable destinations across the universe. This boundary operates with perfect objectivity, immune to human desires, technological sophistication, or philosophical arguments about the nature of cosmic exploration, establishing a cosmic law that applies equally to every potential civilization, regardless of their scientific achievements or cultural perspectives on interstellar travel. Physics rather than technology sets these final limits because the underlying constraints emerge from the geometry of space-time itself. The speed of light as a universal constant, and the dynamics of cosmic expansion driven by dark energy across scales encompassing the entire observable universe. No conceivable advancement in propulsion systems, energy generation, or exotic matter manipulation could circumvent these fundamental barriers because they arise not from engineering challenges, but from the basic mathematical structure describing how matter, energy, and space-time interact across relativistic velocities and cosmic distances. Even hypothetical technologies like warp drives, traversable wormholes, or manipulation of extraspatial dimensions would remain subject to causality constraints that prevent faster-than-light information transfer across cosmic event horizons, ensuring that physical limits on exploration remain inviolate regardless of technological breakthroughs that might seem to transcend conventional limitations on spacecraft performance. The democratic universe ensures that every observer everywhere experiences identical cosmic constraints on their potential range of exploration and communication, creating a fundamental equality among all conscious beings regardless of their location, technological capabilities, or temporal epoch within cosmic history. This cosmic democracy means that advanced civilizations developing within distant galaxy clusters face the same boundaries limiting their exploration as emerging technological societies within our local group, establishing universal principles that apply equally to every possible form of consciousness that might develop within gravitationally bound cosmic domains. Future civilizations billions of years more advanced than current human technology would inhabit the same cosmic cage defined by their local gravitational associations, prevented from establishing contact with distant cosmic neighbors by the identical space-time geometry that constrains our own cosmic reach across deep space and time. Finding meaning within cosmic constraints requires recognizing that boundaries create, rather than eliminate, opportunities for discovery, exploration, and intellectual growth across scales that encompass vast territories, even within the limits imposed by relativistic physics and cosmic expansion. Our local group domain contains more stars, planets, and cosmic phenomena than human civilization could explore across geological epochs, ensuring that the practical scope of scientific investigation and cultural development remains effectively unlimited even while theoretical boundaries prevent expansion beyond our gravitationally bound cosmic neighbourhood. The finite yet vast nature of our cosmic homeland creates perfect conditions for sustained exploration and discovery without the existential vertigo that would accompany unlimited expansion into infinite space, establishing natural boundaries that provide context and meaning for cosmic exploration, while preventing the isolation that would result from boundless dispersal across ever-expanding space-time. Cosmic horizons transform the question of human purpose from one of unlimited expansion across infinite space into the deeper challenge of understanding and appreciating the extraordinary complexity and beauty contained within our accessible cosmic domain. Rather than viewing cosmic boundaries as tragic limitations on human potential, we can recognize them as essential features that create stable cosmic communities, ensure that consciousness never becomes infinitely diluted across space, and establish natural scales for cosmic citizenship that remain comprehensible to finite minds operating across human timescales and spatial perspectives. Tonight, as you contemplate these profound implications of cosmic boundaries, remember that the universe has gifted consciousness with the perfect balance of cosmic freedom and cosmic constraint, creating realms vast enough to encompass dreams of infinite exploration, while establishing limits that ensure such dreams remain grounded in achievable reality, rather than dissolving into the mathematical abstractions of truly infinite space. What ultimate solitude awaits the hypothetical voyager who completes humanity's most ambitious journey, arriving at the cosmic event horizon only to discover they have reached not a destination, but the edge of expanding emptiness, forever severed from any possibility of return to a home world that aged billions of years during their brief subjective voyage. Tonight we contemplate the most profound isolation conceivable within physical reality, the fate of travellers who push beyond all reasonable boundaries to touch the very limits of the reachable universe, discovering too late that their achievement represents not triumph, but exile from everything that once gave their existence meaning and context. The mathematics of relativistic travel ensure that any expedition targeting the cosmic event horizon becomes irrevocably committed to a one-way passage through space-time, as the extreme time dilation effects necessary to compress billion-year coordinate distances into human-scale proper times create temporal disconnections so severe that returning home becomes physically meaningless, rather than merely impractical. During the decades of ship time required to reach maximum cosmic distances, billions of years would elapse within the departure reference frame, transforming Earth from a vibrant world harbouring complex civilization into either a frozen wasteland orbiting a dying red giant star, or perhaps nothing more than dispersed atoms scattered throughout the expanding solar system by stellar evolution processes. The Sun itself would exhaust its hydrogen fuel reserves and begin expanding into a red giant phase approximately 5 billion years from now, eventually engulfing the inner planets before shedding its outer layers to become a white dwarf star surrounded by a beautiful but deadly planetary nebula, erasing all traces of the biosphere that gave birth to the cosmic voyages in the first place. Even if Earth somehow survived this stellar transformation, continental drift would have rearranged the surface geography beyond recognition. Atmospheric composition would have evolved through geological processes, and any biological descendants of current terrestrial life would have followed evolutionary pathways leading to forms unrecognizable by the departed travellers. The cosmic voyager becomes the ultimate time refugee, displaced not just spatially across billions of light years, but temporally across geological epochs, arriving at their destination in a universe fundamentally different from the one they departed. Their radio communications equipment would receive only silence when attempting to contact Earth, as any transmitting stations would have ceased operation billions of years earlier when human civilization either transcended its technological origins or succumbed to existential risks that eliminate complex societies across cosmic timescales. The travellers' arrival at the cosmic event horizon reveals not the exotic cosmic phenomena they might have anticipated, but rather the stark reality of reaching a boundary defined by nothingness rather than substance, a mathematical surface in space-time beyond which no signals or influences can propagate back toward their origin point. This edge of expanding emptiness represents the ultimate anticlimax in cosmic exploration, a destination that exists only as a coordinate location in space-time rather than a place containing interesting cosmic structures, exotic physics, or opportunities for scientific discovery. The space near the cosmic event horizon contains galaxy densities similar to those found elsewhere in the universe. But these stellar systems have become permanently isolated from all other cosmic domains by the relentless expansion of space-time itself, creating islands of matter surrounded by unbridgeable gulfs of accelerating vacuum. The philosophical weight of such a journey encompasses not just the practical impossibility of return, but the existential meaninglessness of having travelled so far only to reach a boundary that represents absence rather than presence, emptiness rather than fulfillment. Unlike terrestrial exploration that discovers new continents, mountain ranges, or oceanic depths filled with novel life forms and geological wonders, cosmic boundary exploration leads only to increasingly empty space, punctuated by isolated galaxies racing away from one another at ever-accelerating rates. The Voyager's achievement in reaching humanity's absolute travel limit would remain forever unwitnessed and uncelebrated, as no communication system could transmit news of their arrival back across the cosmic event horizon to any civilization capable of appreciating their accomplishment. Their scientific observations of cosmic phenomena near the boundary of reachable space would die with them, unable to contribute to the advancement of knowledge within their species' home cosmic domain. The ultimate tragedy lies not in the technical challenges of mounting such an expedition, but in its fundamental purposelessness, as the destination offers nothing that could justify the enormous costs in energy, resources, and human potential required to achieve maximum cosmic range. Reaching the edge of forever proves to be not a glorious culmination of human exploration, but a demonstration of the profound wisdom embedded in cosmic constraints that protect conscious beings from pursuing achievements that lead only to isolation and meaninglessness. Tonight, as you rest safely within the gravitational embrace of our local group home, remember that the universe has structured itself to provide every conscious observer with access to vast cosmic territories for exploration, while simultaneously creating boundaries that prevent the pursuit of distance for its own sake from leading to existential exile. Ensuring that cosmic exploration remains grounded in purposes that enhance, rather than diminish, the meaning and connectivity that give consciousness its value across the deep time evolution of intelligence throughout the cosmos. Why does discovering the absolute limits of cosmic exploration bring not despair but profound peace? And how do the boundaries that forever constrain human reach paradoxically create the perfect conditions for finding meaning and wonder within the infinite vastness of space? Tonight we reach the gentle conclusion of our journey to the edge of forever, discovering that cosmic horizons represent not cruel restrictions on human potential, but essential features of universal architecture that create islands of possibility within an ocean of infinite mystery. The cosmic event horizon emerges as a fundamental characteristic woven into the fabric of reality itself, arising naturally from the interplay between relativistic physics, the expansion of space-time, and the democratic distribution of dark energy throughout the cosmos. These boundaries exist not as arbitrary obstacles placed in humanity's path, but as inevitable consequences of the same physical laws that enable stars to shine, planets to orbit, and consciousness to emerge from the complex chemistry of carbon-based molecules scattered across countless worlds throughout our local group domain. Every region of infinite space possesses its own cosmic horizon, creating a universe where boundaries appear wherever observers develop sufficient sophistication to contemplate the limits of their cosmic reach, establishing a perfect democracy of constraint that applies equally to every possible form of consciousness, regardless of location, technological capability, or temporal epoch. This universal principle ensures that no civilization anywhere in the cosmos enjoys unlimited access to cosmic real estate, while simultaneously guaranteeing that every gravitationally bound domain contains sufficient complexity and diversity to sustain scientific investigation and cultural development across geological epochs without approaching the limits of available cosmic territory. The strange comfort of physical limits emerges from their role in creating rather than destroying human meaning, establishing natural scales for cosmic citizenship that remain comprehensible to finite minds, while preventing the existential vertigo that would accompany unlimited expansion into truly infinite space. Without cosmic horizons, consciousness would face the impossible task of exploring territories that grow without bound, creating obligations and possibilities that exceed any finite capacity for experience or understanding, while simultaneously diluting social connections across distances that make communication and community impossible to maintain. Cosmic expansion ensures that every gravitationally bound region develops its own horizon through the simple passage of time combined with accelerating dark energy, creating boundaries that protect rather than imprison conscious observers by establishing natural limits on the scope of achievable exploration and meaningful interaction with distant cosmic neighbours. The beauty of boundaries in infinite space lies in their capacity to transform overwhelming cosmic vastness into manageable domains where exploration remains purposeful rather than endless, where scientific discovery leads to deeper understanding rather than infinite regression into ever more remote phenomena, and where cosmic community can flourish within scales that preserve rather than destroy the social connections that give consciousness its meaning and value. These natural boundaries create cosmic neighborhoods where civilizations can develop sustainable relationships with their stellar environment, while maintaining the social cohesion necessary for cultural evolution and scientific advancement across timescales spanning millions or billions of years. Our place in the cosmic order reflects not accidental circumstances, but fundamental principles governing how consciousness can emerge and thrive within a universe structured to provide optimal conditions for intellectual and cultural development. The local group represents humanity's natural cosmic homeland not through random chance, but through the elegant mathematics of gravitational binding in an expanding universe, creating the perfect balance between cosmic freedom and cosmic constraint that allows exploration to remain meaningful rather than dissolving into abstract mathematical infinity. Within our accessible cosmic domain lie more stars, planets, and opportunities for discovery than human civilization could exhaust across geological ages, ensuring that wonder and adventure remain inexhaustible resources even while theoretical boundaries prevent expansion beyond our gravitationally bound cosmic neighborhood. Tonight, as you drift into gentle sleep surrounded by the quiet darkness, take comfort in knowing that you exist within a universe perfectly calibrated to provide consciousness with access to vast cosmic territories for exploration, while simultaneously creating boundaries that ensure such exploration remains grounded in achievable purposes rather than impossible dreams. The cosmic event horizon that limits humanity's ultimate reach represents not a cosmic tragedy, but a cosmic gift, protecting us from the existential isolation that would result from unlimited expansion, while ensuring that our cosmic neighborhood contains sufficient mystery and beauty to sustain wonder across all the generations that may follow in humanity's long journey through space and time. Close your eyes and rest peacefully in the knowledge that the universe has structured itself as the perfect home for conscious beings, creating realms vast enough to encompass infinite dreams of discovery, while establishing limits that preserve the human-scale meaning that makes such dreams worth pursuing across the deep cosmic future that awaits our species among the countless stars scattered throughout the gravitational embrace of our local group home. Take a slow breath and feel the gentle motion that carries you through infinite space at velocities beyond comprehension, your body apparently motionless yet participating in cosmic choreography, spanning scales from planetary rotation to galactic drift to universal expansion itself. Right now, as you rest quietly in this moment of contemplation, Earth spins beneath you at over 1,000 miles per hour, while orbiting our Sun at 67,000 miles per hour, racing through the Milky Way galaxy at 514,000 miles per hour as our entire stellar neighborhood circles the galactic center, while our local group of galaxies drifts through space at nearly 400 miles per second toward the gravitational attractor known as the Great Wall, all simultaneously participating in cosmic expansion that stretches space itself at rates exceeding the speed of light across sufficient distances. The cosmic horizon surrounds your current location like an invisible sphere of possibility extending 18 billion light-years in every direction, marking the absolute boundary between the reachable and unreachable universe through mathematical laws more fundamental than any human technology could overcome. This spherical shell represents not a wall built from matter or energy, but a consequence of space-time geometry itself, created by the patient work of cosmic expansion across billions of years as dark energy gradually transforms accessible cosmic territory into permanently isolated regions, racing away faster than light can bridge the growing gaps between there and here. Beyond this cosmic boundary lies forever in its most literal sense, infinite realms of space containing galaxy clusters, cosmic structures, and perhaps countless civilizations developing their own understanding of physics and consciousness, while remaining forever beyond any possibility of communication or contact, due to the inexorable stretching of space-time that separates all cosmic domains from their distant neighbours. Yet this infinite inaccessibility brings not despair, but profound peace. As the universe has arranged itself to provide every observer with perfect cosmic citizenship within gravitationally bound domains, vast enough to encompass dreams of exploration across geological epochs, while establishing natural boundaries that preserve rather than destroy the human-scale meaning that makes such dreams worthwhile. In a universe lacking edges in the conventional sense, expansion itself becomes the architect of boundaries, creating cosmic neighbourhoods through the elegant interplay between gravitational attraction and dark energy repulsion, ensuring that consciousness never faces the impossible burden of unlimited cosmic territory, while simultaneously protecting it from the existential isolation that would result from infinite dispersal across boundless space. The beauty of these cosmically imposed limits lies not in their restriction of human potential, but in their creation of optimal conditions for consciousness to flourish within scales that remain comprehensible to finite minds operating across human lifetimes and cultural timescales. Perhaps the universe structured itself this way precisely to nurture rather than overwhelm the delicate phenomenon of awareness that emerge from billions of years of stellar nucleosynthesis, planetary formation, and biological evolution within our cosmic neighbourhood. Tonight, as sleep approaches and your conscious attention gradually fades into the restorative darkness that allows neural networks to consolidate the day's experiences into lasting memory patterns, remember that you exist at the perfect moment in cosmic history when distant galaxies remain visible through telescopes, even though most have already slipped beyond the reach of any conceivable expedition, creating a universe where observation extends far beyond interaction, while ensuring that wonder and mystery remain inexhaustible, resources available to every generation that follows humanity's long journey among the stars. The cosmic event horizon that defines humanity's ultimate boundary represents not a cosmic tragedy, but evidence of a universe perfectly calibrated to provide consciousness with access to vast territories for discovery, while creating limits that preserve the social connections and meaningful purposes that give exploration its value across the deep-time future of intelligence throughout the cosmos. Rest peacefully in this knowledge, breathing slowly as you participate in the cosmic dance that carries you through space at unimaginable speeds, while keeping you safely nested within the gravitational embrace of our local group home, surrounded by countless stars yet protected by natural boundaries that ensure the universe remains forever a source of wonder rather than overwhelming vastness, exactly as it should be for conscious beings seeking their place within the infinite mystery of existence itself.